Let me just share our slides for the PM session. Sir Ross, can we just have a quick check on your audio and your video? Hello, Sir Russell. We cannot hear you po. Okay, good afternoon, everyone. Sorry, we have a technical difficulty. So for now, let's proceed to the PM session of the first ever colloquium on power and clean energy with the theme Empowering Digital Technologies for the Advancement of Clean Energy and Power Engineering. So this is organized by the IECEP Power Electronics Society and hosted by IECEP Bulacan, IECEP Cavite, IECEP KSA-CRC, and IECEP Mindoro Chapters. By the way, this is Rai Angelique Agda from IECEP Bulacan chapter, and together with my co-moderator, Engineer Russell Vincent Torres, we will be your moderators for this afternoon. Okay, Engineer Russ, the floor is yours. I think Engineer Russ. We can hear you po. While we're waiting for Sir Russ, we'll proceed with the reading of the House Rule first. Just a quick recap on the AM session agenda. We already have two topics, and for the PM session, we'll be having a opening remarks, and inspirational messages from our guests, and then 3 of the remaining topics for this webinar. So for the house rules and qualification for e-certifications, to keep doors open for better communication, greater mutual respect, and greater efficiency, please don't forget to mute your device audio and turn off your webcam during the presentation. Turn it on only when needed. Respect the speakers on the floor. Note that you are allowed to provide questions via the Q&A mechanism of the webinar. We will not be entertaining questions via the chat box. And please, no spamming on the chat box. Create a discussion or ask questions during a discussion period, as mentioned by the speaker related to the topic. Do not close your session or log out during the seminar. You may leave anytime in between, but your login may not be connected as it may interrupt the system. You can log out after the event finishes. Last but not the least, don't forget to fill out the attendance and evaluation form later. The link will be posted at the chat box too. So for those who are asking how to qualify for the e-certificates, first you must be registered and confirmed participant at myicep.net, completed at least 90% of the session, and signed in attendance form. Don't forget to pass the evaluation test and accomplish the webinar evaluation survey. Engineer Russ, are you already there?
Yes, thank you very much.
Okay,
Okay, I'm here.
the floor is yours.
Wait a minute. Continue.
Okay, while we're still waiting for Engineer Russ, we will be having an inspirational message from our very special guest, our very own IECEP National President, Dr. Michelle D. Lawas. Good afternoon, ma'am.
Hello, good afternoon, and thank you very much, Engineer Angelo, for that kind introduction. Of course, I am so sorry that I was not able to attend this morning's session because of a very important, important activity, which is also in line with our capacity as your national president. Of course, before anything else, to the IECEP National Board of Officers, our local and foreign chapter governors, especially to the committee and organizers of this first ever colloquium for the clean power and clean energy for 2022, especially to the collaboration, another power collaboration between Bulacan, Cavite, Mindoro, KSA-CRC, to all the governors heading by these 4 chapters, collaborating chapters, including our valued members, former presidents, as well as to our distinguished guests, to the organizations, our resource speakers who represent, to all the expertise we have this afternoon from the academe, professional, in the academe, in the industry, from all over the country, Philippines, borders, and of course, to the foreign chapters who join us today. Ladies and gentlemen, delegates, a pleasant Saturday to one and all. And of course, greetings from the Institute of Electronics Engineers of the Philippines. And to remind everybody, this is the duly accredited professional organization of electronics professional in the country. So it's nice to note, and of course, I am delighted that after many months since the inception of this subcommittee or the society, it's good to know that the chapter, through the initiative of the governors and of course headed by the society, with a VP internal, with a specialization committee, and some of the important persons related to the solar, and trying to come up with this kind of activity. And of course, my greetings to all of you and greetings of peace and solidarity, everyone. Again, my appreciation to this group of dynamic engineers for coming up an activity like what we have today, colloquium. When we say colloquium, me as an academician myself, colloquium is very popular in academe and research world, because from time to time, we are challenged to come up with a solution, find some answers of the query of the industry. In Education 4.0 and onwards, we are always dedicate an effort and initiative to align the academe and industry gap. relevant solutions to the pressing problems we face in our generation. And as an engineer, of course, we are the front line in addressing the technological challenges. We will be the one to provide substantial solutions. I couldn't just imagine the world without science and technology, without engineers, without scientists, without researchers. Because without invention, without innovation, the science and technology, the world will not grow, will not foster to its science and technology. So when we say colloquium, this is an academic meeting or conference or a meeting of minds for all the academicians pertaining to a specific topic. Any related or relevant topics that will somehow contribute to the development and nation building approach. Apart from that, this activity, of course, will somehow give utmost relevance of our presence in the community where we are present. Power and clean energy. These issues and the challenges faced by the renewable energy industry are many. And we have countless actually challenges and issues faced by the clean energy. Okay, there are some of the many, there are few, tawag natin dito, yung scenario talaga na na-acknowledge natin as an engineer in the community. We have political pressures, one of those government policies. We have also corporate influence, age-old infrastructure, lack of proper battery storage system, or even some of the prominent challenges and present market scenarios stand in its way for a wider adoption worldwide. Okay, so those are some of the factors na we need to address and we need to acknowledge as an engineer. So despite those factors, actually clean energy, renewable energy has undertaken a global adoption as a means to alleviate climate change. Because climate change is not only the business of the one advocating for the climate change, but this is the business of everyone, of everybody. It is free of direct pollution and carbon emission, which is very popular when we say climate change. So it is most visible substitute for whatever it is, yung mga fossil fuels natin and all of that. And time it is becoming an inevitable part of the mix of energy production. So what is good in this kind of colloquium? We associated ourselves in advocating for the clean energy. So there are many line agencies in the government, in the private sector that address the claimor, that address on how to resolve clean energy, because we want to dwell on the clean energy. But we have significant and well-known obstacle to clean energy, and one of those is yung adoption. Yung mag-a-adapt tayo ng clean energy, of course, the first and the foremost challenge is the cost. And this cost, of course, is often associated with, alam na natin yun, mga infrastructure natin and many more. And in fact, I want to share to everybody that I am also one of the members of the one advocating for the clean energy, because in South Cotabato area, in South Sargent area, in Region 12, but particularly in General Santos City, the coal power plant and many forms of power plant is sprouting within the area, and we all acknowledge the how harmful even the emission in terms of the carbon emission of all those things. But the popular one, the carbon emission, are the main cause of global warming. Many efforts, including our advocacy for that, have been taken to increase its adoption. However, the cost is an important factor affecting this adoption. How we wish, we have the wind energy, we have the water, or we have the tidal, then we have the solar. Pero one of the stumbling blocks on the way of its development is the high cost of installation. So of all the energy sources, hopefully solar, this society, as well as wind, is the cheapest ones, and we all know that. However, there is a huge difference in the upfront installation cost of solar power system and a gas-fired plant in the country or even abroad. And that is the reality and the fact that we are facing. It's the initial cost. Nevertheless, IECEP as an organization is taking part in these global issues and predicament to address global warming. It is not the business alone of the group advocating global warming, renewable energy, clean energy, so on and so forth. I believe that with the experts, with our technical speakers we have today, we can be enlightened further of the current situation as far as energy is concerned, as far as renewable or clean energy is concerned. We need to strengthen our coordination, collaboration with the involved line agencies in the government, private sector, and other advocates in terms of policy and framework. Because we are not alone in this endeavor, in this milestone, but we need to coordinate and collaborate with the existing ones. I can assure you of my support along with the national officers to whatever help in these undertakings. What is important? The establishment of the society with legal identity. We need to have that. So engineers involved must possess substantial and enough knowledge so we can deliver or process appropriate information. So again, of course, no, with the industry trends, including not only solar, but including artificial intelligence or even cybersecurity and blockchain taking on the spotlight. Actually, the next years to come shall define us as an organization, including the society of the solar, of this Power Electronics Society, no, and all of the other societies pertaining to the creation of our specialization. So as the institute, as an IECEP, no, caps off our internal programs. So we have many available internal programs provided by the general membership, where in fact we have acquisition of the IECEP Home, no, as our national office. Then we have also empowered and enhanced the use of my IECEP portal. Then the leaders of IECEP can likewise explore other programs or possible programs concerning the practice of our profession, the development and the career advancement of our members. So the inclusivity and the empowerment of programs of IECEP for all of you to participate are here to stay. Organizations' programs are likewise made stronger than ever. So hopefully you can note with that the organizations are taking much of our time to really come up with an exclusive programs for all the members. The ECT, the ECEs and the PECEs, no, are here to stay. And even the student tree and the academe are likewise stronger, made stronger than ever, because we need to cascade down this knowledge to the future generation of our country and the future members of our organization. We need to educate and somehow translate to them the necessary knowledge and skills that we can provide as a society, as an organization to our future generation. So we have also international research platform, no, and similar opportunities for electronics engineers to be. So hopefully we could have many more colloquium and many more activities, not to somehow help out and revitalize our members for the skill development and of course for the technology related activities of our organization. So again, my congratulations to all of you, and of course gratitude to the organizing committee, to the chapters, the collaboration, power collaboration, and this is a good manifestation of your support to the national, because we are needing much more of you today, because we need to really come up with a good programs and activities, because I always believe as your president that the future of our organization, the stability, and of course the continuity of our programs will depend so much of what we are prioritizing and what we are investing today. So with that, again, congratulations and to all the speakers. Hopefully this is not the last. We could have another colloquium. It's a meeting of minds once again. So there are experts coming up with their studies, with their coming up with their ideas, and and results not to specific issues to solar. So again, my congratulations to all of you. And at the parallel side, we have also our second national board meeting, regular meeting for the ISAP National. So from on behalf of the ISAP National, again, my congratulations and good luck to everyone.
Yes, that was a message from our national president. Thank you so much, Dr. Michelle. I have two words I capture on the speech, the word colloquium. For me, I was so puzzled the word colloquium, what it is, the meaning. Now I truly understand. I can equalize it or equivalent to a conference or a COP or the community or practice or a symposium. And also green energy. Yes, Doc Michelle. One of the most important challenges in today's world is the decarbonization of the global economy. This is a challenge for us and electronic professionals. How we adapt or how we can expand renewable energy sources. Such good example, the solar energy. Thank you, Doc Michelle. Can we have some a round of applause for Doc Michelle? A virtual applause. Thank you very much, Doc Michelle.
You
Okay,
are very
now
much welcome, sir. And of course, everybody, thank you so much for this opportunity to be sharing with you in this colloquium. No, this is very timely talaga, empowering digital technologies as ICEP or electronics engineers as being frontline of the advancement of technology, not even the clean energy and power engineering, but as well as the many specialization adhering to the digital technology. So again, my congratulations to all of you.
yes, thank you once again. We are here to support our organization, the EPO. Now let's have our opening remarks. May I call ISEP Mindoro Governor, Engineer Gerald Texon. Engineer Gerald, if you're around, the e-space is yours.
All right, thank you for the nice introduction, Engineer Russ. So, may I comment on your on your outfit? Man, oh man, you are killing it, man. Nice coat, nice hat, and that energy. And okay, so on my speech, okay, so firstly, welcome everyone, professionals and students. So I believe that we have students here in our webinar. So, welcome to our PM session for the ICEP's first colloquium on the power and clean energy. Before we proceed to the three additional exciting webinar topics this afternoon, on behalf of the hosts from the ICEP Bulacan chapter, ICEP KSA-ERC, ICEP Cavite, ICEP Mindoro, and ICEP Power Electronics Group. So hopefully wala akong nakakalimutan. We would like to express 1,000 thanks to all the attendees and guests for today's webinar. This is a very important day for us since this is our very first collaboration webinar, especially with our ICEP Power Electronics Group. So this is our first webinar that has this many participants. So not going to lie. So even this number, right now we are 263 participants. So that's already a lot of people. I mean, for our standards in ISEP Mindoro, since our organization is a low population, so typical population in our chapter when it comes to webinars like this. So um, 30 people is considered a large number of audience. So thank you very much for the participation of a lot of people. Okay, so from the looks of it, so today's webinar is one of our biggest successes in the Power Electronics Group. And definitely, we might do another one of these free webinars in the future. as professionals. So learning should not stop in school. So in today's pace of advancement of technology, so especially in the energy sector, so we should catch up with the trend. So in fact, evolution never stops, progress never stops. So why should we? So it's up to us as professionals or even students. So on how we pace the learning rate, so we could go as slow or as fast as we want, as long as we do not stop learning these new things, even if it's so little, even the little new information, we are definitely going forward. So with that said, let us sit back, relax, and enjoy the new learning, the new things in our today's webinar. So thank you everyone and have a good afternoon. Sir Russ, nakamute po kayo.
Thank you very much. So that was a good catch. That was a good talk. It was about learnings. I believe knowledge is power. The more we earn, the more we have the power. Okay, I would like to request all the panelists and also our national president to please open your special cam for our photo ops. Thank you very much. Please do so. And while waiting for that, okay, Zoom Master, if you're ready, just give us your best shot and give us the cue if we are all done so that we can proceed for our topics. Thank you.
Okay, requesting for Engineer Rai to turn off this share screen so that we could have our photo ops. Thank you.
Smile. Give your best smile, panelists. And also to our attendees, stay put. We have a lots of topic to discuss. So, Zoom Master, are we all in? Please advise. Engineer Rai?
Miss Faye, please advise if you already took the photo shot. Okay, 1, 2, 3. Okay, I think we can now proceed to the next topic, sir.
Okay. Thank you very much, Engineer Rai, my co-host. By the way, I am Russell Vincent Torres of IECEP KSA-CRC here in the Kingdom of Saudi Arabia. Good afternoon, Philippines, and good day to all the nation. Now, Engineer Rai, we will proceed to our third topic. To me, this is a captivating topic because we will be covering digitalization as our ISEP national president mentioned on his speech that we should be the frontliners as electronic engineers in the industrial IR 4.0. For you, what is artificial intelligence, or also known as AI? Why don't we deep dive in the world of this new and fascinating technology? AI is the ability of a computer or a controlled robot to do the tasks that are usually done by humans in the traditional way because they require human intelligence and judgment. Now, to introduce our first speaker of this afternoon event, may I call Engineer Alvaran of ICEP Cavite to introduce the speaker. Engineer the e-space is yours.
Thank you, sir. So I will introduce our third speaker for today. Okay. Our third speaker received his Bachelor of Science degree in Electrical Engineering from Chung Yuan Christian University, Taiwan, Taiwan, and the Master's degree in Electrical Engineering from National Cheng Kung University, also in Taiwan, and the PhD degree in Electrical Engineering from National Tsinghua University in Hsinchu, Taiwan. Sponsored by the Ministry of Education in Taiwan, he conducted research with the Department of Electrical Engineering in the University of Washington, Seattle, USA. He has been a professor in Chung-Yuan Christian University since 1991 and was further promoted to distinguished professor due to his exceptional performance in research, leadership, teamwork, and international collaboration. Between 2006 to 2012, he was the Dean of the College of Electrical Engineering and Computer Science in Chung-Yuan Christian University, and from 2012 to 2018, he was promoted to Secretary General. Currently, he serves as the Dean of the Research and Development in the same university. His research interests include power system analysis and artificial intelligence applications. In 2006, he was a recipient of Outstanding Professor in Electrical Engineering Award from the Chinese Institute of Electrical Engineering in Taiwan and was a chair of the IEEE Power Electronics Society in Taiwan chapter in 2001. Ladies and gentlemen, I'm proud to present our next resource speaker, Dr. Ying Yi Hong.
Okay, thank you for Jason's introductions. I'm going to share my screen. So can you see my screen?
Yes, sir.
Okay, good. I'm going to switch to the presentation mode. Okay, so I think that the time is very limited. I have to stop at the 2:20. So I would like to speak as quick as possible. It's a real honor for me to have this opportunity to keep this talk in this afternoon. The title of my presentation is Application of Artificial Intelligence associated with Takushi method to power and engineering, energy engineering. So here is my outline of my presentations. First, I will give the overview, the backgrounds of artificial intelligence, and then I will introduce the Takushi method. The Takushi method will be applied to help the artificial intelligence to be more powerful. And I will give you three examples for applications. The first one is how to integrate the artificial intelligence and the Takushi method to produce the training data for artificial neural network. And the second one, I would like to use them to tune the hyperparameter and the topology of deep learning neural network. And the third one is to use them to generate scenario for designing parameter of controller. And finally, I will draw some conclusions. So let's take a look at the backgrounds of artificial intelligence. I don't know if you watched the movie, Imitation Games before or not. It's a good movie to show you Dr. Alan Turing. The Alan Turing, we can say, is a founding father of computer science. He published papers talking about some concept of computers. Actually, during that time, there is no computer. But he published a paper talk about, and he proposed some questions. The first one, is there any thought without experience? Is there mind without communication? Is there language without living? Is there intelligence without life? And can machines think? Actually, it's a very popular and very famous thing. He published this paper. And the second one is John McCarthy. John McCarthy, he is developed the phrase the artificial intelligence. And we can say it's a founding fathers for the AI. He gives the definition of artificial intelligence. And he says that AI is the science and engineering of making intelligent machines, especially intelligent computer programs. So it became the founding father of artificial intelligence. So who will be the artificial intelligence? Right now is a very popular and well-known terms. Actually, the artificial intelligence cover many things, many items. For example, in 1960s, the first artificial intelligence system we call the expert systems. Expert system is a rule-based system. And this rule-based system cover many rule knowledge base from the experts. For example, the first expert system is Dendro. Dendro is a rule-based system developed for the molecular structure of Martin source. And the second example is Mycin. Mycin is a rule-based system for diagnosis of infection blood disease. And these two expert systems were developed by the Stanford University in the United States. And then some people developed the fuzzy rule-based. Fuzzy rule-based is more powerful than the expert system. And in 1975, a professor in UK, Professor Mandania, proposed a rule-based inference to deal with Boyer engine systems. And the Japanese scholar, Professor Scano proposed a fuzzy inference system. They are also very powerful in 1985. But both the expert system and rule-based system cannot learn from the experience from the historical data. So some people develop some machine learning algorithm to learn from the past data sets. For example, artificial intelligence. Artificial intelligence can be divided into two learning algorithms. For example, they can use the supervised learning algorithm and the unsupervised learning algorithm. Also, one of the machine learning, powerful machine learning method is the evolution algorithm. Like the genetic algorithm, we can use some mathematical to model how to use the gene or chromosome to perform crossover mutation and the evolutions process to learn from the historical data. But right now, the most powerful artificial intelligence tool we call it deep learning. For example, convolutions, neural network, and long-term, short-term memories. And I'm going to detail some of them. The first one is artificial intelligence, artificial neural network. Artificial neural network can be divided, as I mentioned about super learning and supervised learning and supervised learning. For the supervised learning, we will give our network target. So we will train the neural network to learn some things. The purpose of supervised learning is to train the neural network for classification, predictions, and diagnosis, and regressions. And let me see if I can have a point here. Okay, And the purpose of unsupervised learning, we can use these kinds of the neural network for future extraction, clustering, and to reduce the dimension of the data. So here is an example for the meanings of the classification, and we have to find a straight line to separate the two sets of the data. So this is a classification. For regression, for example, we want to find a straight line to look like to describe the characteristic of this data. And also here we find the clustering. Clustering is to set a three group automatically. So these three groups can be separated properly. So this is for the unsupervised learning. So for the biographical neural network, I think it's around 70 years ago. Some medical doctors, they check the neural system in our body. They find that there are some elements in our neural cell. The soma is the neural body here, the soma, and the dendrite here, like the input, some signal to our neural cell. And here, synapse can, to enhance or to reduce the signal from the outside. And the embryon can output the signal to another neural cell. So here we can use the neural cell to model the neural cell by mathematical. So we can have a neuron. It looks like a soma. And here is the input signal, for example, X1, X2 to the Xn. And here is the weight. Weight can enhance or reduce the strength of the signals. It's like a synapse. And here we could have some output. So by the mathematical, for example, we have some signal 2, 3, and 4. And for each signal, we have a weighting factor. And we can sum it together. But we have to compare to a bias. It's a threshold. So compared to the bias, we can get 1.27 is our output. For this output, we will input to we call it an activation function. The activation function will give a constraint for the output to limit and smaller than 1 unities. So here is the basic model of the mathematical for a neural cell. So we can compare the biological neural network and the artificial neural network. Soma is our neural, dendrite is our input, endosome is our output, and the synapse is our weight. So here we can show because the neuron cannot exist only one. So we need a lot of neuron put it together. And then the neuron could have many, many layers. Here we have an input layer. And here we have a middle layer, for example. And here we have an outer layer. So this is a very typical architecture of the neural network. So for many applications, we not only have one hidden layer, we many have many different hidden layers. For example, here we have first hidden layer and for the second hidden layer. For different purpose, we could have a different number of input neurons and different numbers of output neurons. And here, so I want to give you some concepts about the deep learning. Here, I just give you one example. For example, convolution neural network. Well, so how deep a neural network here? I show you an example. For example, we have 1, 2, 3, 3 hidden neural network. And there are actually many neural in the hidden hidden layer. And there are many waiting between the neural. So when we train the neural network, it will become very complicated. So we have, maybe we have 2 questions to ask. The first one, in a traditional neural network, get a better result if the number of the hidden layer become large. The answer is no. Because if we could have a lot of neural or a lot of number of hidden layer, this neural network will become overfitting for the historical data. So the answer is not. The second question is how to extract the future of input data. So if we use the most popular supervised learning algorithm, then we cannot extract the futures of input data. Actually, it will take quite a long time to train a neural network. But maybe we can use the unsupervised learning algorithm to extract the data of the extract the future of the input data. So how to detect and extract futures of 1 dimension, 2 dimension, and 3-dimensional data? And each detector must move around. The most popular way is to use convolutional neural network. So, well, so what will be the futures? For example, for a people, we can identify, we can see the eyes and the nose and the mouth or even the ears. Then we can know who is this girl, who is this boy. So we can identify a people by the futures of the future of a people. So we can know who is this. So for the same reason, if we want to extract the data, then we can know the characteristics of the data and know how to achieve the purpose, like the regression, like the classification, like the predictions. The next page. So to develop a deep learning neural network such as convolution neural network, based on the mathematical studies, we know the all operation in our mind, in our brains, is based on the cortex in our brain. For example, if we examine our brain, the cortex, the surface of our brain, for example, when we examine the area 6, well, area 6 is deal with the auditorious system. If we check area 8, it deals with the visual event. If we check the area 9, then we know area 9 will have something to do with the association. So different areas in the cortex of our brain, we can know they have different functions. So how to do these functions? Well, based on this understanding, we develop a convolution neural network. This is a this neural network have convolutional layers, and all the convolution layers have a number of filters, and all these filters can perform the convolution operator. like this one. And this filters is the purpose of this filter is to detect the features of a data, especially for the two-dimensional image. The next term is the strike. So what will be the kernel of the filter to how fast is the filters of the kernel to detect the features of the data? Well, we will consider the speed, the moving speed of a window. So we can, the window can move very fast, and or the window can move very slow. Here's I can show you some example how to perform the convolutions operation. For example, here is our original data, and we can add some zero around the original data. We call it a zero padding. And here is our filters, and we call it a kernel. And here we perform a convolution operations. So if we consider the location 2, 3 is here, nice. So we can take a convolutions operation and to attempt the final result. The final result here we call is a feature map. So if here is a original data, for example, and we have, for example, we have 2 filters, and all these 2 filters have to be trained. That means all these filters have to be, this value inside the filter have to be trained by supervised learning. This one and this one, they are unknown. We need to train to get all this result. So for each result, we can detect a small pattern 3 by 3. So for example, here, filter 1, and we map to this small area 3 by 3, and we take a convolution dot product. Then we can get the results 3, and then we assume we have a strike equal 1. Then we will move 1 step, and then we can get another value -1, and move. If we have a strike 2, then we will get another different value, -3. So let's back to the strike 1. Here we got 3. Here we got -1. And here we got -3. And here we got -1. And we move down here, then we get -3. And in total, we get a lot of value. And this is the last inner product. And then we get this value. So this is for filter 1. Okay, let me skip this. Okay, for filter 2, we will get the same value and repeat. We will repeat this the same process and get all the value. For filter 1, filter 2, sorry, and move 1 step to get another value. Repeat 1 step, get this value, and get this value. Okay, so we have filter 1 and the filter 2. So we get a final future map. We get these 2 final future map, for example. So we have a 4 by 4 image forming 2 by 4 by 4 matrix. So after the convolution, we have to perform max poolings. For max pooling, assume we have a window size. The window size is 2 by 2, and the strike is 2. So we can find this one, we get the maximum value for here, 8. We put the 8 here, and we consider this area, and we have 7, and we get this area. So we get 7 again. Then we consider this area, and we get 9 again. So this is called a max pooling. We can also consider average pooling. The average pooling we also consider, for example, this area, and we take the average value, and here we can get 5.25. And if we consider this area, then we can get the average value. For example, here 5.5. For the same reason, we can get 3. And for the same reason, we can get 4.5, for example. So why we need pooling? Because we have the sub-down or sub-assembling pixel. And with sub-sampling pixel, so one not change the object, but just reduce the size of the images. Okay, so we still can recognize what is the original the image, who is the girl, the Laura, okay, in the image. So we can repeat many times. We can conduct convolution, max pooling, convolution, max pooling many times. So the last step is to flatten. Because right now we have many features, we got many pictures, but we need to drop out some information, because a lot of information will cause our neural network overfitting. So we need to drop out something. So the first step is to flatten. Flatten, that means to put all information together here. But all the flattened information, we need to drop out a little bit in order to reduce some information to avoid overfitting. So the final result will become something like this. For all informations, we will have to flatten and put it to the fully connected neural network to identify who is this girl, for example, here. So then the next artificial intelligence method is fuzzy rule base. The fuzzy rule base here, so first term I want to introduce is the fuzzy set. The fuzzy set. So what is the fuzzy set? In the fuzzy theories, a fuzzy set is defined by a function we call it a membership functions. And for each membership functions, we said there is a degree for an object, and this degree is between 0 and 1. And this degree represent the membership. We call it membership functions, membership values in the element in the fuzzy set. For example, like this, here is the degrees of the membership functions. And then the X here is the mean, the height of a boy. For example, we have how many? We have 5 fuzzy set in here. This one is the fuzzy set for a tall man, and this one is a fuzzy set of very tall man, and here is a fuzzy set for average man. And here is a fuzzy set for short man. Here is a fuzzy set for very short man. For example, if a boy is his height is 185, this boy belongs to, for example, here a tall man. This boy is also belong to a very tall man or average man, but their degrees are different. So here, assume that we have 3 rules. For example, the first rule, if is X is A3, Y A3, Y is B1, then Z is C1. The second rule, if X is A2 and Y is B2, then Z is C2. If X is A1, then C is C3. So where the X1, A2, A1, A2, A3, B1, B2, and the C3s are fuzzy set. And we have an input X1 and we have input Y1. Then we can get difference the output. For the first output, we get, for the first rule, we get this output. Here is the output for the second rule. Here is the output for the third rule. But all the rule was partially fired. So here we need to combine all the result for the rule-based system. So how to combine this process we call is the applications. So we combine the output from the rule 1, rule 2, and the rule 3 to perform the aggregation and get this output. But this output is still a fuzzy set. So the last step is to defuzzifications. To defuzzification of this fuzzy set, the most popular way is to use the center of gravity. Well, we will use the center of gravity to calculate. Here is our final result, 67.4, 67.4 is our final result. So here is the backgrounds of artificial neural network and the fuzzy rule base. I'm going to show you in the next 3 examples. So here's what it will be the quality engineering. The quality engineering is based on the experiments, design of experiments. Design of experiments is the statistical techniques that is used to study the overall effect of multiple variables on the output. And this quality engineering is which proposed by the Dr. Takushi, is commonly known as the Takushi method. And the Takushi method is a form of design of experiments with spatial applications. So if we consider 4 factory combinations to do the experiment, for example, here's if we have a 15 design factor, and each design factor have 2 labels. If we consider 4 factory experiment, then we have to do more than 32,000 experiments to complete, to achieve all the experiments. So actually it's very time consuming. It will require a lot of times. But Dr. Takushi developed a special set of orthogonal array for standardized fractional factor design of experiment. And it's only requires very limited numbers of experiments. And all experiments can be carried out, and all the necessary information can be still acquired. So here, for example, is a small orthogonal experiment. Assume that in our problem that we have 3 designed factors, and all the 3 designed factors have 2 labels. So we have to do only 4 experiments to carry out all the study. And there are 2 very important orthogonal property. The first property is a column contains the equal numbers of all labels. For example, this one, 1, 1, 2, 2, 1, 2, 1, 2, 1, 2, 2, 1. And the second property is a combination of the label in any 2 columns appear equal times. For example, if we consider here 1, 1, 1, 2, 2, 1, 1, 1, 2, 2. And also we consider here, for example, 1, 1, 2, 2, 1, 2, 2, 1. They appear equal numbers of time. So these two property we call is orthogonal. So Dr. Takushi proposed a lot of two-level libraries. So we can follow all the orthogonal experience according to this library. And also he developed some three-level library, for example, like this. So for the Takushi method, we have to define a process. The process, it means the mechanicals of application. We also have to define the signal or input. The input is to start the system. And then the most important one is the factor. The factors, that means that they will produce some intended objective to control the product of the system. And also there are some uncontrollable noise. These noises are available, they are known to affect the output and are either unidentifiable or economically uncontrolled. And the output are also maybe some response of the system or the performance of the index. And the response evaluate can be some performance of the index. And the output could be better, is better, maybe it's larger is better, or the small is better, or the normal is better. So here I want to give you the first example. The first example is about the fault detections, classification, and location by static switch in the microgrid. Okay, here is the example. This example, the microgrid, as mentioned about the speaker in this morning, is very popular and important nowadays in the smart grid. And I want to use some techniques based on the Takushi method and artificial intelligence to deal with these kinds of the problem. Okay, this problem is when we talk about the microgrid. Microgrid is very small, the electrical power system. It can accommodate different distributed generation, energy storage. So like this one, here is the utility, and here is the microgrid. But the microgrid may have some fault that maybe occur like the inside the microgrid, or maybe it's the outside the microgrid. So this research presents a method to detect, classify, and localize the fault inside or outside the microgrid by using the Takushi-based artificial neural network. And I'm going to use the entropies of wavelength as the input to the neural network. And the training data are all orthogonal set. Because most of the neural network will require a lot of training data set to train the data, to train the neural network. But in this research, we use the orthogonal data set by Takushi's experiment to identify this, the fault. And the result, we will use the microcontroller and use a real-time digital simulator to output the fault current and implement a 50 kVA stated switch to show the capability of the proposed method. So what will be the noise in the Takushi method? The noise is the fault type. Actually, we have, I think that there are 11 fault type. For example, balanced three-phase fault, and unbalanced two-phase fault, for example, and one-phase fault to the ground. And the input, there's three locations. The first one is the zone A, the second one zone B, the third one the utility sites. And the control factor we have four control factors. The first one, we define the different load label, wind speed, irradiance, and the short capacity, short circuits capacity. So we will use the wavelet transform to produce the signal. Because of the time, the limitation of the times, I'm going to skip the wavelet transform. But I can say the wavelet transform can provide the different signal in different frequency bands here. And the wavelet transform, is similar to a Fourier transform. Fourier transform is, I think, is very popular. But the wavelet transform, few people know what is the wavelet transform. Well, Fourier transform is suitable for periodical function, but wavelet transform is suitable for the transient signals. There are two orthogonal bases for Fourier transform, sine and cosine. But wavelet transform will have a scale function and a wavelet functions. Okay, but actually they are very similar, So we will use the output of we will use the output of the entropy of the wavelet transform as an input to the neural network. So here we design a neural network. We have how many neurons? So we have 7 neurons as our input. And we also have 7 neurons for our output. The output here we defined here. So for example, here, if the output is 0, 1, 1, 1, 0, 1, 0, that means we have a fault at B, we have a fault at C, we have a fault to the ground, and this fault occurred at zone A. So that means we have an unbalanced to ground fault. B, C, and the ground fault occur at zone A. So we can design this neural network to identify the fault conditions in the microgrid. So how many experience, how many training data we have to use? If we follow the Takusi's experiments, so actually we only need the 306 to consider different areas, different types of fault. But if we consider full factory scenario, how many data, how many training data we need? We need 2,754 data training set. So the ratio of the reduction here is 88.89% to generate the training data. So here's in our lab, we will use a real-time digital simulation because we cannot go to the realistic microgrid to generate the data. So we will use the digital real-time simulator to produce the data to output the fault current, the fault signal to implement the hardware. And our neural network has been implemented in the chip, microchip. Microcontroller is a RX622. So we are connected the fault current, the real-time digital simulation with the microchip together. So here is the output that we can test and to check the accuracy of the testing data. Well, our proposed measures will attempt 100% accuracy to identify the fault type, the fault locations. We also compare the result. We also use the result attempt by the decision tree. Decision tree is another machine learning method. And also we attempt, the result is compared to another neural network. we can find that our accuracy can attempt 100%, but the other method cannot. And we can check the resource attempt by the RX62 microcontroller. They are almost the same. Here is the final result that we implement to set up to check the to develop a 50 kVA stylistic controller rectifier based on the hardware, and to do the result, to do the experiment. And here is the result. We can find this can get our design can get a very good result, 100% accuracy. Okay, here is the maybe it's the final example. Because of the time, I hope I can finish this example. Because this example is a day ahead spatial temporal the wind speed forecasting method. But actually, this method can also be applied to, for example, solar irradiance forecasting. You can use the same method to conduct this if you want to do the same research. So, do we really need the 2D image for UCC convolution neural network? Because the convolution neural network is quite popular to deal with the images of processes. But our problem is the renewables energy rather than the image process. So we want to, in this research, we will take advantage of a spatial temporal information to perform the wind speed forecasting. Similar, we can use the same method to carry out the solar irradiance forecasting. Here we want to know the hourly wind speed next 24 hours at the location L3 here. Location L3 is a location in Taiwan. And we have historical hourly wind speed data here. So how can we do it? How can we do it? Well, how can we do it without the need of the image? Because the convolution neural network is just for the images problems. Well, so in this research, we will take 2 dimensions. One dimension is time. One dimension is space. So with to these 2 dimensions, we can use the spatial temporal characteristic of the data to become a 2D dimensions as a 2D image. So here, we will check the difference. We will have to take advantage of different information from different areas. The first area is the Philippines. I don't know where it is, but I can find this location in the Google map. And one area in one location in South Korea, and 4 areas in China. And here is our targeted locations in Taiwan. So in this problem, we have to consider different problems here. The first one is the system. The system is the structure of the convolution neural network. It includes the convolutional average pooling operations. And also the input. The input is a 2-dimensional wind speed data from the 7 sites in Taiwan, China, Philippines, Korea. And this is maybe the most important one. Because we want to design a convolution neural network, we have to consider how to design a convolution neural network. Well, we have some hyperparameter and the structure parameter. Here is the parameter we have to design in the convolution neural network, like the cascade layer, parallel layer, number of convolutional, number of kernel, and kernel size, zero padding, dropout, and the number of the hidden layers in the neural network. And we also have a different uncontrollable noise, like the wind speed in the four seasons. They have different characteristics. They have different characteristics. Here are our noise. So the output is the performance of the neural network. So we define the deterministic coefficient between the actual and the forecasted values. So we hope the deterministic coefficients between the actual and the forecasted value should be as large as possible. We can follow these formulations. So here we use the orthogonal array like here. So we have to carry out the 18 experiment, but we have to consider false theorem. So we have to consider false theorem. And based on the result, we have to calculate the signal to noise ratio. And to check the average effect of factor labels. So the what is the ultimate design for a neural network? The ultimate design, the ultimate values of a design in the robust designs is the label with the largest average factor of factor label. So here is, for example, is the final signal noise ratio. And we can check the average effect of factor label for each design factor. And for example, for the design factor A, we can find the label 1 is the best one. For design factor B, the best label is label 3. For the design factor D, the best label is also label 3. Here is the definitions of the design factor. So here we can get the final robust design, the 2D dimensional convolution neural network like this. It's very complicated deep learning algorithm. We developed this neural network. The unknown variables here in this system, is more than 10 million variable. And we compare the result here with other methods. Well, here is our proposed method. We can check, if we check the errors, the forecasting error, we can find the error we find for the winter season is the smallest one compared to the other deep learning method. And here is the summer data set. For example, here, our error is the smallest one. Our error is the smallest one. Okay, I don't think so. I have enough time to go to the details of the third example. I have to jump to final conclusions and to answer all the questions you have. So in the conclusions, this talk addressed the application of artificial intelligence and the Takushi method, which is widely used in the quality engineering. And also, the Takushi method also gonna reduce the number of experiments. And in the first example, the orthogonal experiment generate much less numbers of required data to train an artificial neural network. And here is the second example. In the wind speed forecasting problem, Takushi method attempt a robust hyperplanes and topology of the convolution neural network. I think that my time is up. I have to stop here for you to ask questions here. Thank you very much for your attention.
Okay, thank you very much, Dr. Hong. While waiting for the Q&A portion, Once again, thank you, Dr. Hong, for interesting subject of the about artificial intelligence. For me, I think it's not a mundane activity because it's added value to our learnings about AI. Example, what is shown to us, the artificial neural network, or how energy sector can adapt this technology. Dr. Hong, once again, regarding the movie about imitation game, I watched that movie exactly. It was a British film about World War using the actor imagination on how to decode the enemy's plan to attack the allies. It was so precise. I love that game movie, by the way. It was a true story, I believe. Anyhow, how about our attendees? Did you get the learnings about AI or the Tagasushi method? So, if you do so, please hit your keyboard with letter Y. If you have a little understanding what is artificial intelligence, even though you have seen a lot of this topic or discussion in every forum, hope this will give you an idea for the starter, particularly our student. Okay, so we will proceed with the Q&A portion. Engineer Rai, the e-space is yours.
Thanks again, Engineer Russell. So we will be moving to the Q&A portion of the event. As mentioned earlier, we already have pre-selected the questions for our speaker with the limited time that we have. And again, reminder to please send your questions to the Q&A mechanism of the Zoom. Engineer Reynaldo Pagador, you may now flash the questions. For the first question, um, what is your basic idea or approach that you can apply CNN between a moving T 4x4 and a fixed reference T 4x4 that will give response when they are matched in datasets? Dr. Hong?
What do you mean? What is the basic ideas approach that you can apply it between the moving 4x4 or and they will give the response they are matching the data set? I think they can match the data set. Here, sometimes we can use the 3x3, 2x2, 4x4. But you know, if you use the 4x4, it's a larger window size. So it's better to to give a stride equal to 1 to small stride. So in order to get a good result, I suggest the basic idea here to consider here is to use the stride 1 in order to match all the data set. So I think that different window size and the different stride will give different result. So the most best one is to use the robust design. So for our robust design, we will consider different window size, even different stride, in order to get a robust one. That's my answer.
Thank you, Dr. Hong.
Okay, the second one is our libraries are already available for common programming language. Yes, the library is already, you can find in the website or in the textbook or in some commercial tools. Yes, so all libraries are already available. Yes.
Okay, thank you. Thank you for answering our questions. Let's move on to the awarding of the plaque of appreciation. Let me call Engineer Revenal A. De Jesus, ASEAN Engineer and PECE, the Vice Governor for Internal Affairs of IECEP Bulacan. Sir Rav?
Hello, good afternoon. We'll now proceed to the awarding of certificate to our valued resource speaker. Can we flash the virtual certificate of our speaker? The plaque of appreciation on the behalf of the Institute of Electronics Engineers of the Philippines, we would like to express our gratitude to Dr. Ying Yi Hong for sharing his time and experience during the first IECEP Colloquium on Power and Clean Energy with the theme, Empowering Digital Technologies for the Advancement of Clean Energy and Power Engineering via Zoom meeting on February 12, 2022, 8 a.m. to 6 p.m. Thank you very much, Dr. Hong, and congratulations.
Oh, thank you for your invitation and thank you for your attention for my speech. Thank you.
Thanks again, Sir Rob and Dr. Ying Yi Hong. Ms. Faye, can you please flash our attendance form and speaker evaluation for our participants? Thank you. Engineer Russ, you may go on.
Okay, thank you very much, Engineer Rai. We are going to continue our fourth topic of the event. Before that, I would like to ask attendees, fellow professionals, students, are you still with us on this afternoon event? Please be with us. Relax, setbacks, and enjoy the show. So the next topic is a very well-known topic among us, especially electronic engineers, particularly in the field of telecommunication. To add, this is an alignment again with the digitalization. Telecommunication, by the way, plays an integral part of the IR 4.0 and helps make the people life easier. Imagine, this is very true with the use of our smartphone. Now, to introduce our fourth speaker, may I call Dr. Jodelex of IECEP Cavite Governor. Dr. Jodelex, the e-space is yours.
Thank you, Sir Russ. Good afternoon, my dear participants, electronics engineers, guests, and IECEP Inc. Local and national officers. Our fourth speaker for this first IECEP Colloquium on Power and Clean Energy is a professional electronics engineer since 2017. He has a master's degree in management engineering and over 12 years of industry experience handling strategic planning, digital transformation, design and solution, project management, and operations of ICT and telecommunication for the biggest electric utility company in the Philippines, or Meralco. He obtained his Bachelor of Science in Electronics and Communications degree in TUP Visayas and Master's degree in UST, which he graduated as cum laude. Furthermore, my dear colleagues, our fourth resource speaker is a board exam top-notcher. He is the 18th placer in ECE board examination in year 2005. He has specialization in smart grid and operational technologies communication. And this afternoon, he will share his expertise on application of digital telecommunication in power and energy sector. My co-engineers, please welcome and give a virtual round of applause to our fourth resource speaker, the head of Telecommunications Engineering Division of Meralco, an expert, Engineer Juan Carlos Lam. Sir JC, the virtual floor is yours.
Engineer JC, if you are ready to go, just give us your cue. Engineer JC?
Hi, can you hear me now?
Yes, loud and clear. The e-space is yours. Go ahead, Engineer JC.
Thank you. Thank you, Engineer Russell. Okay. Again, good afternoon, everyone. So this will be a continuation of our discussion this morning. This morning, more on the overview of the smart grid roadmap and where we are right now and where we're going. And this afternoon, we will be discussing. We'll be more focusing on the communications technologies, no, that we have been applying for the for smart grid. Okay, so let me share my screen. Okay. Okay, so coming off from this morning's discussion, we will be focusing right now on the communications technologies for ANA and AMI and some future telecommunications technologies that we're looking into. So this is just a brief recall slide from what was discussed this morning about smart grid being a two-way communications enabled electric system that uses intelligent devices and systems to mainly to improve the network reliability, efficiency, and power quality amid the emergence of distributed energy resources. And to face on the challenges of the 3Ds, no? The decarbonization, distributed generation, and decentralization and digitalization. And last but not least, to empower customers via enhanced energy management. So I've discussed this morning about ANA and AMI. Now we're going to focus on what are the communications technologies behind this smart grid pillars. So for advanced network automation, this focuses more on the grid's ability to manage the grid more efficiently, enhance network reliability, and for better management, including the DERs or the distributed energy resources. For the customer benefits, it's more on the improved customers' quality of life and satisfaction on the power quality and potential savings due to energy conservation. Now, in this architecture, we have field devices on the bottom. So these are different field devices installed in substations, the field. And we have the communications infrastructure, the communications layer in the middle to connect these devices to the back-end systems. Now we're going to focus on the middle part, the communications. So we have in the backend system, we have the SCADA or the Advanced Distribution Management System that enables distribution management system and outage management, runs the Fleesier and EVO, fault location, isolation, system restoration, and integrated volt var optimization for sectionalizing the circuits if in case there are faults, and ensuring the power quality. And in the middle we have the communications infrastructure. So we have different communications technologies being used, depends on the use cases, and we're gonna tackle it in the succeeding slides. To connect basically the line devices in the field, so we have distribution transformer monitoring, fault circuit indicators, even smart meters now for AMI. But smart meters are also being used for ANA because smart meters have the capability to measure parameters, that we can use to connect to the distribution transformers. Konting kwento lang, there was a case, no, during the start of the pandemic, around 2020, no, nung early part pa ng pandemic, wherein most of us, no, nag-work from home, no, yung mga students sa bahay na rin nag-aaral. So there was a sudden surge of demand, no, do sa sa residential, and there are some circuits wherein nag-overload yung mga transformers natin. Kasi biglaan no, biglaan. So it wasn't accounted, hindi na foresee yun. But because of that learning, then distribution transformer monitoring, no, through smart meters are being put in the pipeline to monitor, no, the status of the transformers, and to have that visibility on the customer's usage, no. Makikita natin if a certain barangay tumataas yung usage, and bago pa man mag-overload, no, pupuntahan na ng Meralco yun to put on additional transformers or upgrade the capacity of the transformers. No, yun yung isa sa mga learnings na nakita natin during the pandemic. And we have liner closers, remote controlled liner closers for fault location, isolation, and line capacitors naman and voltage regulators for the EVO, volt var optimization. If in case may mga voltage drops, then strategic areas, we have voltage regulators to balance, no, to improve the circuit, and line capacitors also. Remote terminal units, these are installed mostly in substations to connect the IEDs, no, yung mga intelligent electronic devices. For example, yung mga circuit breakers, yung mga protection relays, yung mga devices dun sa mga substations. It is being connected to the RTUs for monitoring and control. No? That's the very essence of ANA, to have the visibility to be able to monitor and control the circuit and the distribution network. So for the communications infrastructure, we have several technologies. Isa-isahin po natin yan mamaya. So we're going to be focusing on number 1 and number 2, no? Because ito yung mga areas where telecommunications really plays a vital role in delivering these initiatives. And okay, so we will start with distribution automation, the FLISIR and the EVO. Okay, fault location, isolation, and service restoration FLISIR. So as mentioned this morning, this is very important to sectionalize, no, the circuits. Basically, we're talking here about the primary lines, no, yung mga 34.5 kilovolt lines, primary distribution lines. So yun yung mga linya na before the transformer, no, nung nasa mga poste. After the transformer, it is being converted to 220 volts AC papunta na sa mga bahay natin. But before the transformer, yung primary distribution line natin, which is 34.5, mostly 34.5. In some areas, iba po yan, depende sa cooperative or distribution utility. But for Meralco, it's mostly 34.5 kilovolts. So the purpose of the FLISIR is to sectionalize, no, yung ganito. So imagine natin that this is a circuit, no, and this is a primary line. Here's ito. Let me. So for example, so these are substations. And these are the feeder lines, the 34.5 kilovolts lines. And somewhere here, for example, there is a barangay, no? May barangay dyan. Dito meron din, no? If a fault appears here, it will this device, no, will isolate the fault. So ang ma-out lang ito. Itong area na to will still have electricity coming from substation A or substation B. Or in this case, no, kung pag nagkaroon ng fault dito, ang ma-isolate lang yung area na to, but the other customers na naka-red will still have their electricity, no. Without this, lahat yan damay-damay. So imagine how widespread the brownout will be, you know, compared to having this distribution automation system. And the good thing about this is that whenever there is a fault, automatically these devices transmits telemetry data to the SCADA, no, or the DMS to analyze if the fault is temporary, then it will reclose, no, or if the fault is permanent, then a crew may need to go there to fix it, no. For example, may natumbang ano ba? For example, may tumaas na puno, no? Yung puno masyado nang mataas, umabot na doon sa primary lines, and nagkaroon ng fault, no? So magti-trigger ito. And nakita na yung fault is recurring based on the data. It means that it's kailangan puntahan ng crew, no, to cut off the tree branch na, no. But if it's a it's a temporary, let's say merong crane na nakatama dun sa primary line na nagkaroon ng fault and nawala din naman, then it will reclose, no, these devices, kaya tinawag to na reclosers, because if the fault is temporary, then babalik lang yan ng kusa, no. Unlike before, wherein pupuntahan talaga ng Meralco or lineman to reconnect the line, no, which will take time. So kahit isang bibiyahe pa yan, so mahaba yung brownout. Unlike ngayon, minutes or even seconds lang, it will be restored. Okay, so this is the primary benefit of the FLISIR, no, faster service restoration, resulting to shorter customer downtime and enhancement of improvement in the reliability. So for the EVO naman, this is more on the optimization or the management of the circuits, and pag nagkaroon ng mga voltage drop, no, there is a voltage regulator and capacitor banks na magti-trigger to ensure the power quality is good, no. So the communication technology that being used here mostly is the narrowband radio, no. By the word itself, narrowband, we're using small bandwidth, no, up to 25 kilohertz lang, maliliit lang, no, because telemetry data is relatively small, no, and we're using, mababa kasi yung frequency band natin, usually ito 300 to 400 megahertz, and ideal siya for longer distance coverage, but syempre you have to account na hindi ganun kalaki yung bandwidth, no, na makukuha. But for SCADA applications like this, it's really enough, no. 25 kilohertz, you can get a data rate of 30 to 100 kbps per remote radio. And based on our calculations, acceptable RSSI and signal to noise ratio, RSSI is negative 85 dBm. You can have acceptable, magandang signal, no, acceptable signal to noise ratio of 30 dB. That's on a typical Philippine setting, no. Like I mentioned this morning, most of our distribution automation deployment here in Meralco's franchise area is suburban, no. A few portions of our area lang, Makati, BGC, somewhere in Quezon City, Ortigas area, dun lang tayo nagkakaroon ng challenges sa line of sight because of the buildings. But mostly, you know, it's the challenge is on the terrain, no. When we go to the areas of Rizal, the south area, Batangas, nandun yung challenge dito sa terrain. But this narrowband radio, ang kaganda naman nito is it can reach further compared to broadband radios like LTE. No, and we have seen that typical remote radios usually nakakuha tayo ng mga digital modulations of course may mga magaganda tayong nakuha, 64 QAM, umabot tayo ng 64 QAM and 16, and meron ding mga ito yung mga malalayo, no? Usually 40% of the population ng isang base stations nakakuha tayo ng mga QPSK, but still acceptable, no? Now a base station may accommodate up to 20 remote radios. Depende, no, on the sa dami ng mga reclosers din sa lugar niyon. But it can accommodate around that 20 counts. So these remote radios are connected to the line devices and placed atop poles, no. So later I have some pictures here to show you kung paano yung ini-install sa poste, no. Okay. So, and base stations naman, these are usually located inside substations, no, or privately owned locations na pwedeng i-lease or bilhin. We're currently exploring then yung possibility of putting up base stations in Meralco poles if especially for those challenging areas like yung mga bandang Rizal and sa mga bandang Batangas, yung mga bulubundukin na hilly areas. Some of the design considerations here, when we compute for the capacity, we should also consider cybersecurity encryption, as usually it's 10% of the total traffic load. 10% also for network management, and then 10% for on-demand emergency data traffic for commands, no, and mostly 65% for the data traffic for the monitoring. So we can view this as a highway wherein we allocate a special lane for sa mga ambulance, no. Pag may mga kahit na traffic, pag may ambulansya, makakadaan pa rin, no? So we employ quality of service, no, QoS settings infrastructure for traffic prioritization, no. Yun yung especially pag may mga use cases tayo wherein there's an emergency that command needs to be transmitted to the line devices, kailangan priority yun. Okay, and so those are some of the design considerations. Well, nowadays we have the privilege to have these tools, no, available in the market that we can use. These are licensed RF planning tools, similar to what telcos are using, but ito naman naka-tuned in, no, naman dun sa specific use cases like this one, like the distribution automation. So what we do here is we plot, no, we plot some of the devices in the field, and then we run the software preset na dun sa mga parameters and settings ng radio system, and we get this coverage profile. The green one is the good signal, no, and then blue and yellow and red. We can set it up in such a way na depende naman sa magiging calibration, no. Kinakalibrate natin to in terms of actual installations for us to ensure na accurate lagi yung tool natin, no. And we also do apply several propagation models, no, depende on the use case. propagation models are the main algorithm in these tools, no. So for example, if it's a highly urban area, there's a specific propagation model that may be used to specific for urban areas compared naman dun sa mga rural areas, no. So depende na sa setting nung tool yon. So here, for example lang, we build a base station here, no, to cover the pins with covered in the green spots, no. So parang ganito yan. So a base station connects to different line devices in the field. So these are all pole-mounted devices na sa field, while the yellow ones are the substations, no. So in terms of NTCs and RFAT, revision 2019, the frequency band that we're using for public utility services is here, no. Yung 385 to 399.9 megahertz, 385 to 390 for the transmit, and 395 to 399 megahertz receive shared users for public utility service. So that's where Meralco is using the frequency for the distribution automation. Now shared users ito, ibig sabihin other users can also use this band, no, pero meron silang dedicated naman na frequency license for them. So ito yung example niyan. Ito yung line device, no. Ito yung recloser. Ito yung primary line natin, the 34.5 kilovolt line. Yung secondary line natin, ito yung mas mababa, yung 220 volts, no, ito. So ito yung remote radio natin that's connected to an antenna, no. It's a usually Yagi antenna lang yan, directional papunta dun sa base station. So basically we use the same setup, whether it's for Flisier or Evo, no, same lang yan. Same lang naman yung mga data na nakukuha sa CCU or yung yung control unit, no, nung sa SCADA. So same with other SCADA applications all over the world. We're using the DNP protocol for the SCADA communications. And Modbus, no, yun yung mga protocols that pwede natin gamitin in accordance to the standards. Now let's proceed with the substation automation. So as mentioned this morning, dalawa yung substation setup natin. Merong conventional and merong compliant na do sa IEC 61850 na standard, wherein digital devices connected in a redundant communications network using fiber optics and using the IEC 61850 standard for communications, the goose messaging. So here we have communication bus and the station bus, the process bus and the station bus, no. So yung mga IEDs natin connected sa gateway, no, pinaka gateway natin. So we have some yung mga CTPT devices natin, intelligent switch gears, and yung mga IEDs natin, no. Now the main benefit of an IEC 61850 substation is that there is no need na for hardwired communication sa mga IEDs, no. Previously these are all hardwired using copper wires, no. Napakadaming kable. But with IEC 61850, meron na lang tayong communication bus that reduces system installation costs, no, increases the reliability of the system, and improves operational efficiency. So this is the most dominant worldwide standard for communications for substations. The use of fiber optics instead of copper wires, and integrates protection, control, measurement, and monitoring functions. Now we're talking about the substation LAN lang, no. So sa loob lang yan ng substation, wherein different IEDs communicates to the gateway, and yung mga devices natin sa labas, sa yard, and then when it goes to the gateway, it goes to the control center na, using our wide area network infrastructure. So ito na yon, paano siya makakapunta sa control center typically, and this is the typical setup for substations then all over the world. Usually it has a primary network and a secondary network for redundancy. Here, ito yung SCADA RTU or the gateway, and it connects to the IEDs. Now the substation LAN is on this side, yung sa left side, and hindi ko na lang sinama because you already discussed it on the previous slide. That's the substation LAN, the process bus and the station bus. Now, when it goes to the SCADA RTU or the gateway, it goes to the wide area network to the control centers, or the SCADA master or the advanced distribution management system. Sa ibang bansa ganun na rin eh. And then also it's also a typical practice that we have a backup site, kung sa data center pa, we have a DR site, for enterprise data centers. For operations technologies, we also have backup sites. Now, in terms of the wide area network, ito yung dalawa yung wide area network natin. Usually it's for redundancy. Mostly ang nakikita natin ngayon is the trend is really going into packet-based transport network. As some of you may be aware, previously meron pa tayong mga circuit-based systems like yung mga synchronous digital hierarchy, yung mga SDH, which is still, by the way, being used right now. Hindi naman basta-basta natin pwedeng i-retire yan without considering yung effect dun sa mga loadings. But the trend really is going into IP, and packet transport is really the one that will replace the SDH in the near future. And one of the most widely used technology for packet transport is the MPLS, which is enables a very fast switching of data. So there's the MPLS system has also other facets like the IP MPLS for pure IP and the MPLS TP, as a transport layer for that really the advantage is more on adapting some sort of the circuit-based capability of the SDH, because in terms of electric distribution communications, we need to consider the factor of symmetry, symmetrical path for predictability, especially if later on we'll tackle more on dun sa line protection. Kailangan kung saan ka dumaan, doon ka rin babalik. There's a kung kumbaga if lagi kang dumadaan ng EDSA pag pumupunta ka sa office, pag uwi mo dapat doon ka rin dumaan, para symmetrical yung path. The concern with some packet-based transport is that it's always on it's fast switching protocol is also based on OSPF, meaning kung ano yung parang parang nag-waze ka, so pag pupunta ka sa office, mag-waze ka, NC Waze sasabihin sa iyo kung saan yung magandang path, doon ka dadaan, kasi sabihin niya traffic sa EDSA, dito ka dumaan sa kabila. Tapos pag pauwi ka naman, mag-waze ka naman, sasabihin naman ni Waze na ito naman yung other path na maganda para sa iyo. So merong factor na ganun pag packet transport. But the thing for OT communications is we have to consider then the symmetrical factor of communications, yung predictability, especially for line differential protection communications, because the main factor here is the latency. It should be able to support low latency communications. No, later we will tackle more on that. Now, now similarly, no, ito rin yung nakikita nating setup sa ibang bansa. You have the packet-based transport, no, for the primary. Or yung iba SDH pa, it's okay, and using optical network equipment, no, so mostly using fiber, no, yun yung primary network natin. And yung secondary network natin mostly naman are using microwave radio. And we also seeing the trend of microwave radio going to IP na rin, no. Previously mga E1 pa yan, no. PDH, no. Pero ngayon it's also the trend is also going to packet-based transport. So here, so nowadays, no, we have given the privilege to have these tools, no, which we can use to make our lives easier, kumbaga, no. Kung computing for the link budget, may meron ng mga tools ngayon that can do that for us. As long as lagi lang updated yung mga database natin, we can compute for the link budget. Now, ito yung transitionary natin, no. Right now we're still using multiplexers, no, in the power industry, mainly because the move to have a full IP implementation is still a long way to go. No, unlike with enterprise applications sa IT, wherein pure IP based na, sa OT iba, no. We can still see that most of the SCADA applications and SCADA devices in the field are still using serial communications interfaces, no. And pag serial yan, nahihirapan tayo na kung serial yung endpoints and IP yung one mo, paano mo gagawin yon, di ba? So, and but fortunately, itong mga multiplexers, no, na nakikita natin ngayon, the trend is also going into IP, no. These are IP based multiplexers, no. Yung wide area interface nito are IP based na rin, unlike before na STM pa or E1, no. So before ang backbone mo SDH, tapos yung edge mo multiplexers, no. But as you transition into IP, if you're doing digital transformation sa companies ninyo, as you transition to full IP, no, you will start doon sa edge. And then, but if the edge is masasabi nating lagging pa, no, kasi may mga serial pa tayo diyan, then we'll start doon sa core, yung wide area network natin, no. So ang kagandahan naman ng mga multiplexers ngayon, they can adapt to if your backbone is SDH, then you can use some E1 interfaces dito, or if your backbone is MPLS, pwede ka naman gumamit ng mga yung mga Ethernet interfaces din. So that's what we're seeing right now. And these are widely used, no, especially sa mga substation automation, because these are multi-service multiplexers, no. Pwede kang mag low speed serial, high speed serial, even Ethernet, no, or E1. To interconnect yung mga core backbone natin, we are using fiber optic, no. And in the power industry, the most predominant fiber optic type that's being used is the ADSS, or the all dielectric self-supporting cables, and the OPGW, or the optical ground wire. Mostly nakikita natin to ginagamit ni NGCP, yung OPGW nila. Yung sa atin naman, sa mga distribution utilities naman, ADSS, no? OPGW because dalawang ang ano niyan ang purpose niyan. It can provide fiber optic dun sa loob, and yung sa labas naman pwedeng grounding cable. And mas matibay to, no? Kasi bakal yan. Mas mababa ang maintenance niyan. But what distinguishes transmission companies from the distribution ones is that yung mga transmission companies like NGCP or Napocor, no, Transco, nung dating panahon, mga ano yan, yung mga tower nila malalaki, no? Tapos yung mga cross country hindi dumadaan sa kalsada. So yung mga towers nila dumadaan yun sa mga palayan, no? Cross country, mga malalaki yan. Kaya pag naglagay tayo ng fiber doon sa taas ng mga OPGW, most of the time bihira na masira yon, no? Unlike pag sa mga distribution utilities wherein yung mga fibers and telcos, no, these are installed sa mga poles, electric poles na along the street. So prone siya sa mga wire down, no, fiber cut, aksidente, or minsan theft, no. Minsan napapagkamalan nitong copper, pinuputol ng mga magnanakaw. Pero pag nakita nila na fiber, pinapabayaan na lang nila, no? Nilalagarin nila yan. Pag nakitang fiber, hinahayaan na lang nila. But ang effect noon, there is nagkakaroon ng mga network outage. But ito yon, yung dalawa na and mas mahal ito, no? OPGW. Now we'll proceed with line protection. One of the most important application of telecommunications is in the line protection system, or tinatawag natin na communication assisted relay communications, no? Wherein substation A and substation B are connected via transmission lines or sub-transmission lines, and it needs to be we need to have fault management mechanism, no? Kapag nagkaroon ng mga fault dito, no? Now we're talking about na yung transmission lines and sub-transmission lines, no? Kanina dun sa primary lines 34.5 kVs, ang protection natin doon are the flexier devices, no? But for substation to substation connections, meron na tayong tinatawag na relay protection. So these are devices that transport protection relay signals from one substation to another, no? The transmission of these relay signals is crucial in containing an electrical fault, thus preventing blackout or outages in the power grid. Ngayon ito mas critical, no? Kapag nagkaroon ng fault dito, hindi lang blackout, no? Hindi lang brownout, blackout ang potential na pwedeng mangyari, because we're talking about massive outage, buong substation out. And as I've mentioned, ang critical dito for the telecom, as far as telecom is concerned, is to ensure that the latency is very low. Is very low sa communications, because mabilis din yung fault eh. Pag nagkaroon ng fault dito, no, somewhere here, it will transmit doon, no? Kapag nagkaroon ng, halimbawa, nagkaroon to ng path to the ground, no, magkakaroon yan ng reverse current flow. Mabilis papunta doon sa substation B. Kailangan mabilis din yung comms to isolate substation B as soon as possible before the fault arrives there, no. So kaya very critical yung latency, like I said. That's why if we're putting relay protection in packet-based transport communications, we have to ensure that meron tayong mga latency control mechanisms in place, no? Ayan, so we're talking about here yung mga subtransmission lines na, so yung mas mataas na yan. These are non-insulated na, yung mga 115 kilovolt lines. Some common types of faults, yung mga unbalanced faults, three-phase faults. Pag yung isa doon sa three-phase, nagkaroon ng fault, ang tawag doon unbalanced fault, no? So tatlo yan sa three-phase. Yung isa dyan, halimbawa, nagkaroon ng path to the ground, tawag doon single line to ground fault, no? Kapag yung isa medyo dumikit doon sa isa, ang tawag diyan line to line fault, no? Or yung dalawang linya nagkaroon ng path to the ground, ang tawag diyan double line to ground fault. So these are the most common na yung mga unbalanced faults. For example, crane touching the lines, a car crashes to electric pole, overgrown vegetation, or even lightning strikes. So kapag nangyari yan, we have to contain the fault, no? Make sure na hindi na yan kumalat pa sa ibang lugar. Similar din yan kahit sa bahay natin, di ba? Kaya tayo may mga circuit breakers sa bahay para pag may fault, no, hindi kumalat, no? Mag-trip agad yung breaker. Kaya kailangan mabilis yung pag-trip. So here, this is just an animation on how the line protection works. So first, let's say a fault happens somewhere here in the line, and the circuit breakers will trip, no? And the protection relays will send trip signals. It depends on the mechanism of the relay protection. Meron tayong tinatawag na line differential protection, which measures the current differential between line one, between this side and the other side. Or meron din namang distance, tinatawag na distance protection, wherein pag sinabing distance, we're talking about the impedance of the line, no? So yung relay na to, it will sense immediately that sa zone niya nagkaroon ng fault. That's why magti-trip siya agad. However, kailangan niyang sabihan si protection relay sa substation B that he also needs to trip para ma-contain ng fault, no? So let's say may puno dyan na tumama dito, nagkaroon ng fault, na permanent yung fault. So the circuit breakers will trip and the protection relay will send trip signals. Okay. So this is where us as electronics engineers come into play, no? To ensure that the teleprotection and our communications infrastructure will work, no? So the teleprotection equipment transmit the trip signal from substation A to substation B via the communications network. And the protection relay will receive the trip signal and trip the breakers accordingly. Ayan, the fault will be contained and the power line segment with fault will be isolated from the rest of the grid. Now, yung loads ng substation B, hindi naman mawawala yan kasi meron pa siyang isang source, no, from another substation. So, masaya tayong lahat, no, yung walang brownout. But imagine if wala to, then the fault will go to this and potentially makaka-damage yan ng mga equipment natin. And it will have massive outages, no, blackout. So that's how yung mga communication systems here come into play in terms of line protection. Now, typically, meron din tayong redundancy features na we employ, no, as a best practice sa buong mundo. Usually we do have a wired and wireless setup for the relay protection, no? So fiber optic, direct fiber optic connection for the relays, and meron din tayong wireless radio link. Pero kailangan ma-contain mo yung latency. So, hindi pwedeng maraming hops nung microwave radio dito. Kailangan mabilis, no? So, sa sa experience ko, for distance protection it's usually maximum of 3 hops. More than that, we can get latency na of more than 50 milliseconds, which is nasa boundary ka na noon, no? Communication latency of less than 50 milliseconds is okay for distance protection, but for line differential, it's another thing. Mas mababa yung latency requirements. Now, meron tayong tinatawag na open access transmission service rules, no? OATS rules from the ERC that requires us, no, pagdating sa mga teleprotection, requires us to provide at least two communication mediums for relay protection, especially if it pertains to the connection to the transmission network provider or NGCP, no. So in this case, section B 5.7 of the OATS rules requires the transmission customer to provide redundant teleprotection paths to the connection point of the transmission network provider. So let's say this is a Meralco substation and this is an NGCP substation. So we need to put up two mediums, no. So it could be fiber, power line carrier, or microwave, no, or is a mix. Basta dapat dalawa. No? Kung mag fiber ka man, they should, provided that these two links are routed through different paths. Walang common. Okay, so typically, ito yung mga setup natin. You can have a PLC. So pag PLC naman, yung signals dumadaan na mismo dun sa transmission line o power line carrier. So that could be your primary link, and your secondary link could be your wireless radio. Yan. Pag may mga distributed energy resource like embedded generators, ito naman, no, it can be a fiber optic cable na dalawa din, but may mistake dito kung isa lang napakita ko, or a 1+1 radio configuration. So yun yung sa advanced network automation, no? So we discussed about distribution automation, yung mga narrowband radio infrastructure. We also discussed about substation automation, yung substation LAN and wide area network being used, and yung mga line protection. Those are critical communications infrastructure that supports advanced network automation. Now, yung next discussion natin will focus on the AMI naman. What are the communications technologies for AMI? So ito, as discussed this morning, AMI consists of smart meters, a communication layer, and the backend system. So typically similar din yan sa ANA, except that for ANA, the field devices are yung mga nasa poste, yung mga nasa substation. Ito, the field devices are smart meters itself, yung nasa bahay natin. So it enables remote reading, remote connection, disconnection, outage meter regularity, consumption monitoring, and reporting. Now, pagdating sa AMI, meron na tayong tinatawag na T-rings. So yung tier 1 natin, yung tinatawag natin na neighborhood area network, no? The neighborhood area network pertains to the communication from the meters, yung mga nasa bahay natin, to an aggregator or a comms gateway. hanggang doon yung NAN. No? There are different technologies for NAN, which we will discuss later on. The second tier is the field area network, this one. So from the gateways, magkakaroon ng backhaul, and the last one is the WAN. No? And then we have platforms na, no? sa right side. We have operations platforms, customer platforms, enterprise and data platforms. No? So yung ano natin, if we will employ analytics, no? Advanced neural networks, predictive analytics, nandito na yon sa data platforms. No? Lahat ng consumption behavior ng mga consumers will be able to learn, no, through the data platforms and make necessary necessary measures. No, so pag nakita natin na tumataas yung consumption ng lugar na to, then we can divert some of our resources there, no. By doing so, no, nagkakaroon tayo ng intelligent mga informations towards an intelligent decision. That's what the essence of having a smart grid is all about. So for neighborhood area network, so ito yon, mga smart meters communicates to a comms gateway. So the NAN is the communications leg that provides the link between the smart meters and the communications gateways. So these communication gateways consolidate the meter data taken from a certain area. So some of the technologies here, it could be a direct interface, like a direct connection via wired medium, maybe a serial connection, or fiber. RF mesh, which is a very popular technology being used mostly sa US. Data is collected through a smart meter with aggregation functionality. The standard here is the IEEE 802.15.4 G and E para sa physical and data link layer. And it's it's a widely used na, no, under WISAN. In the Philippines, per NTC regulation, we are allowed to use this standard, but limited only to this band, no, the 915 to 918 megahertz band. This is a shared band, 3 megahertz for this use for RF mesh and other IoT devices, no. So yung mga LoRaWAN, ito rin yung ginagamit, 915 to 918. So this was lobbied to NTC a few years ago because walang dedicated band for IoT. And ito yung binigay ni NTC, no. Hindi na siya nagbigay ng mas malaking band because ginagamit na yun ng GSM. So ito lang, no, 3 megahertz na shared band. So if we want to use this band, this is a shared band, meaning lahat ng another party can use this band, but on a non-interference basis, no. That's why yung mga technologies na ganito, yung 802.15.4, meron tinatawag yan na frequency hopping, no, spread spectrum, for interference mitigations. Because if an RF mesh is being used in a particular area, and simultaneously there is a LoRaWAN also that being used there, hindi sila nagkakaroon ng interference. So another technology is the wired communications naman using PLC, no. Now sa PLC, there are two widely used standard, the G3 PLC and the PLC Prime. Hindi ko lang nalagay dito yung PLC Prime, but G3 PLC is mostly pang interference mitigation, but low bandwidth yung PLC prime naman, high bandwidth. And last but not the least, the narrowband IoT leverages on existing telco infrastructure using LTE technology. So sa ibang bansa, ito na rin yung ginagamit nilang neighborhood area network using narrowband IoT, no? So it uses it's another flavor of LTE, no, yung LTE-M. But right now kasi sa atin, wala pang, although there has been several talks, no, with Smart and Globe about this, but currently this is not that widespread pa na that's being implemented. Unlike sa ibang bansa kasi na very madami nang gumagamit nito, no. Sa atin wala pa masyado. Of course, because there's wala pa naman kasi masyadong demand for IoT sa bansa natin. Once AMI it will ramp up na, then probably doon na dadami yung demand. So yun yung NAN, no. When we go to the FAN, ito na yung aggregation natin sa backhaul. So some of the technologies being used here, first is the GPON. Uses fiber and offers high bandwidth for a wide ecosystem of FTTX applications. So ito rin is for field area network aggregation. So yung mga communications gateways natin, ito yung mga data concentrator units, mga gateways connected na, no, through fiber. So yun sa GPON. Or we can use LTE, you know, as the broadband backhaul naman, you know, via wireless. Another one is the WiMAX. But in terms of WiMAX versus LTE, mukhang ito na talaga yung nagpo-proliferate, no? Right now, as far as I know, for WiMAX wala nang masyado. Before, telcos are using WiMAX, but slowly they're taken over by LTE, no, as the main 4G technology. Ngayon wala pa dito yung 5G because I'm just nilagay ko lang kasi dito yung mga real life applications na, no, ng FAN. But of course we can use 5G naman. So ang kailangan natin dito broadband link na, because the FAN is an aggregator of several DCUs, no, and gateways. So marami ng meter data yan. And kailangan ito yung mga narrowband pa yan, but this one is broadband na. Now for the one here we're seeing na rin yung mga packet-based, high-speed packet-based transport like yung MPLS na nabanggit kanina. Kasi from the one, no, yung itong mga to, these are all packet-based ano na rin communications eh. So diretso na yan sa mga packet-based transport network. Then from there, it will proceed to dun sa mga platforms na. Now, this I'd like to to discuss a little bit about the adoption of standards for AMI. For AMI, the DLMS COSEM is the most widely used data exchange protocol, no, or the language ng mga meters. Like tayo, no, we're discussing here, lahat tayo Pilipino, so we're using Tagalog as the most widely used language or dialect. So ganun din yan yung mga machine-to-machine communication, especially for smart meters. DLMS is the most widely used, no, defined in the IEC standard 62056. So the adoption of the DLMS will enable a utility to explore interoperability with different meter brands, no. So parang halimbawa lahat tayo English, we're using English as the language, then madali ka mag-integrate ng iba't ibang brands ng meters, no. Unlike may Japanese or Chinese na language that mahirap pa na kailangan pa i-translate. So that's the concept of the DLMS under IEC 62056. Now the standard for the comms naman iba-iba, no. So it could be standard for fiber like mga TCP IP na standard protocols IP or RF mesh, no, yung 802.15.4 and open standard for wired comms, the G3 PLC. So it's very important to consider, no, yung adoption of these standards in building your AMI infrastructure. Otherwise, you might put into a situation where makuha mong system is proprietary and mahirapan kang mag-expand, no. So ganun lang. I'm just saying this for the information of everyone that building an AMI infrastructure is really important to consider open standard communications. Some of the use cases of AMI, which I think was discussed already this morning, itong mga to, no? So once you have the AMI na, then you can have the K-load, no? Pwede ka nang mag prepaid service, pwede kang mag postpaid plus, pwede kang mag home automation assistant, elevated metering centers, and AMI for non-residential. So iba-iba na, ang daming use cases na pwedeng gawin. Right now for Meralco, and dito pa lang tayo sa kuryente load, no. But slowly as we ramp up our AMI infrastructure, we'll be able to support other use cases for the consumers. Example lang ng K-load. Oh, sorry. Ayan, no. So this is particularly very popular for yung mga apartment complex, no, na nagpaparent ng mga condos nila or apartments. Yung iba nagre-rent tapos iniiwan na may utang sa Meralco, di ba? So ito na tingi-tingi na, no, yung pag-load ng kuryente. So for discussed din this morning, ito pa lang yung approved, no, yung press rules or the prepaid electricity service rules. Wala pa tayo nung AMI rules, but we're going there, no, with the help of ERC and the collaboration of the utilities. We'll be able to come up with the AMI rules, no, which is important to start the rollout of AMI, no, sa buong bansa. Net metering, one of the use cases then of AMI is for net metering, no. Right now, as mentioned this morning, meron pag nag-net metering ka, kakaroon ka ng dalawang metro, no. Yung isa yung rec meter, which is capable of recording both import and export energy. But in the future, a single bidirectional smart meters can be developed to replace na yung dalawa pang meter, no. That you need to measure your import and export energy if you want to sell it back to the grid. Advanced outage management, you will be able to identify if there's an outage ahead of time. Home area network, no. These are potential AMI services that Meralco and other utilities can make use of, no, kapag may AMI na. demand response. Ito yung distributed energy resource, EV management, and smart street light. Smart street light can be extended pa into smart cities, no? Meron tayong mga model of smart cities na tinitingnan. And not only, pag sinabing smart city, ito yung, it's not saying buong city, but probably a small area where you're using technology, no? Na meron kang mga smart street lights, meron kang smart meters, meron kang mga EVs, EV management, smart parking, no? So may nakikita na rin tayong mga ganito sa ibang bansa, and eventually for us here in the Philippines, we can make use of this, no? Kapag may mga of course it will be expensive pa sa ngayon, but later on these are some of the potential use cases that we want, no? Usually nakikita natin kapag may mga binibuild ng mga bagong communities, like yung mga bagong condominium units, no? Tinitingnan din nila to. So this is the end of my presentation, but as mentioned this morning, hindi ko na ipakita yung video because of the lack of time, but if you allow me, I'll show that video. Mabilis lang naman.
As Engineer JC, go ahead. We have still time for you. Proceed.
Okay, sir. Okay, let me share.
Off the coast of Quezon Province in the Philippines, 60 miles away from Manila, lies the island of Cagbalete. Known for its powdery white sand beaches, crystal clear waters, and diverse ecosystem, this island paradise has become a sanctuary for travelers seeking respite from the hustle and bustle of the city. But for the people of Cagbalete, the remoteness of the island has become an impediment in gaining reliable access to one of today's most basic of necessities, power.
Ang itsura po nitong isla, puro generator lang. Isa lang nagpapailaw dito sa isla. Hanggang sa, yun, dumami na. Kaso nga lang sir, medyo mataas na yung sa kuryente. Depende kung anong kabit mo. Bawa, may 20. So, pag ang kabit mo sir, ilaw lang. Pero pag may mga TV cut sa electric fan, ayun, minsan 35 na isang gabi. Pero pag mag-overnight, yung magdamagan na 70, doble na kasi yung price nila.
Based on the flat rate charged by private diesel generator owners, at 40 to 70 pesos for 12 hours of electricity use, Cagbalete residents could pay a few thousand pesos per month for their consumption. The electricity cost in Cagbalete can be a hard pill to swallow relative to their monthly income. Families had to prioritize other needs over access to electricity, resulting in nights lived in complete darkness. That all changed in 2019 when Meralco, the largest electric distribution utility in the Philippines, powered one of its microgrid projects on the island, enabling the delivery of reliable, affordable, and sustainable power supply to hundreds of households in Cagbalete. A microgrid is a small-scale, self-sufficient energy system designed to power off-grid communities through a combination of distributed energy sources, including solar PV, wind turbines, diesel generators, and energy storage systems. Through the use of smart technology such as advanced software and control systems, the microgrid is able to operate autonomously without being connected to the main network of transmission and distribution lines. The microgrid pilot in Cagbalete is part of Meralco's intensification of its efforts to achieve 100% household electrification across its serviced area. Back in December of 2019, 2% of households under Meralco's franchise area were not yet electrified. Most of these are located in far-flung areas and remote islands, where extending the distribution lines is impractical or not feasible, such as in the case of Cagbalete. By placing the microgrid infrastructure in Cagbalete, not only did the residents gain access to a more reliable source of power, but also to affordable electricity. Residents now have access to their total monthly consumption through Meralco's digital metering system.
Meralco has taken broader steps in developing a more sustainable energy future for our fellow men. The implementation of our Cagbalete microgrid project is a realization of our commitment to energize communities and empower our customers. We leverage sustainable and smart technologies to shift from traditional diesel generators into clean, renewable energy such as solar and battery energy storage, a step to reducing Meralco's carbon footprint while providing stable power.
The first phase of the Cagbalete microgrid consisted of a 60 kilowatt peak solar photovoltaic system, a 150 kilowatt-hour battery energy storage system, and 2 units of 30 kilowatt diesel generators, which allowed the microgrid system to provide affordable and sustainable energy to the 140 households of Barangay Cagbalete 1. Since then, Meralco has begun building an additional 1.4 megawatt peak solar photovoltaic system and a 2.4 megawatt-hour battery energy storage system for the microgrid's second phase, which will provide clean and sustainable power to more than 600 households, as well as most of the resorts on the island of Cagbalete by the end of 2021.
I think we have been able to establish through Cagbalete that we can provide these types of solutions, and the plan now is once we've fully energized the entire Cagbalete Island is to take the solution beyond the franchise area and up.
By bringing light and power to remote communities, Meralco aims to spur economic progress in the area and improve the livelihood of the residents. Energizing the island of Cagbalete allowed us to provide not only electricity, but also the hope it brings to its people who are used to relying on candles in the middle of the night. Powering a community, lighting the path of the fishermen on their way home, providing means for children to focus on their education, and nurturing businesses to spur employment opportunities. Power is life-giving, as it is a critical infrastructure that will help boost the tourism potential of the island.
This will greatly improve tourism to the island and boost its economy as well. What's more, the microgrid paves the way for the improvement of the basic infrastructure of the island, including the construction of a telco tower.
Kasi alam namin ay magkakaroon ng supply ng kuryente mula sa Meralco ay makakatulong ng malaki sa negosyo, sa hanap buhay ng mga tao, saka sa edukasyon lalo tigit. Sa bahay mismo, makakatutok sa pag-aaral yung mga bata.
Meralco commits to providing sustainable, reliable, and cost-effective energy to every home through the use of new and emerging technologies realized through microgrid projects such as that of Cagbalete. By improving energy inclusivity, especially in off-grid communities under the Meralco Electrification Program, a brighter future lies ahead for the Filipinos.
There are a number more islands that are under consideration by Meralco. It's important for us, mainly as part of our social program for our people.
Ngayon po namin naunawaan yung slogan po ninyo na maliwanag ang buhay, masaya. Eh talaga po, napakasaya.
Okay. Thank you.
Thank you.
Thank you, Engineer JC. That was really interesting presentation. Smart grid technologies. There are plethora of technologies in the market nowadays for IT, OT. But in this presentation, it gives us idea what are those, especially to our 260 plus attendees on this virtual meeting. Remember, fellow electronic professionals, wire and wireless communication play an essential role in the energy sector, which was fully explained by our speaker, which means This is our field or our scope of professionals. Take it from me, from someone who works in the field of telecommunication. It is an eye-opener. Microgrid in the Balete Island, driven by the solar power system, it was a maze. To add, it is also environmental friendly. Life changed rapidly among the residents. Now, let's proceed with the Q&A portion. Engineer Rai, my co-host, the e-space is yours.
Thanks again, Engineer Lam and Engineer Russell. We will now move to the Q&A portion of the event. We have selected questions from our first speaker. If you have more questions, you can also drop in the Q&A box and we will reach out to you for the response. Engineer Jerko Sevilla, you may now flash the questions. Engineer Jericho, you may now flash the question. For question number 1, is your utility considering system reliability, analytics, and study? From Engineer Joel Ardona.
Oh, yeah. Thank you. Thank you for this question, Engineer Joel. Yes, system reliability is one of the most important area where Meralco is putting efforts on, no? Because ERC kasi, no, it gives targets to utilities, no. Meron tayong tawag na guaranteed service level, no. In terms of system reliability, the reduction of system loss, may ano yan, may binibigyan si ERC na cap, no. Hindi ka pwedeng lumampas diyan, no. And pag lumampas ka diyan, may penalty, no. But if you are able to do good and achieve more than the cap, then may incentives then from the ERC. So yeah, system reliability, analytics, and study. This is from this morning session. I've tackled a few points about data management and how data will be starting to be more important factor in the in the studies like this. So yes, this is considered, no, analytics and study through the data that we gather through data historians, through the data that we get from the field. And building a data platform is also very important because yung data platform mo, yun yung parang gateway mo to do analytics, eh. In the data platform, of course, meron kang data lake, doon mo i-dump yung mga data mo. And then you have analytics and artificial intelligence tools, no, to interpret those data, especially for system reliability. I think Engineer Joel also has another question, if I can answer it na dito. He asked about this one. Yeah. Who prepares engineering plans, signs, and seals for SCADA, EE or ECE? So for Meralco, it's EE, no, the one that does this. But for telecoms, for the telecoms portion, these are the ECEs naman that do the sign and seal. So depende, no, for example, if a substation needs to be built in a certain area, the local government usually has so many lists of permits, including EE permit and electronics permit. So iba-iba din yung mga pumipirma.
Okay, thank you so much, Engineer Joel, for the questions and for answering and explaining it, Engineer Lam. Oh, we have another question from Engineer Herman. With the smart meters, do you still deploy meter reading personnel?
For those areas that already have smart meters, wala na, no. These are the areas in Manila, no. Some parts of Manila, Pasig, Cavite, no. kasi as mentioned, the AMI is still a pilot at this point. So konti pa lang talaga yung mga smart meters natin. But for those areas, no, hindi na tayo nag-deploy ng mga meter reading personnel. That's why it's important when we consider deployment of AMI, we need to consider per area na deployment. No? So sa isang barangay, pag pinalitan natin yung mga meters ng smart meters, dapat lahat. No? Kasi kung sa isang barangay, kalahati doon naka-smart meter, kalahati hindi, pupuntahan pa rin ng mga smart meter readers natin, di ba? Pupunta pa rin sila sa lugar na yun. So that's why critical din yung deployment plan ng AMI, no? That it should be contiguous.
Okay. Thank you, sir.
Thank you.
Again, if you have additional questions, you can still drop questions on the Q&A box and we will reach out to you for the answers. For the presentation of plaque of appreciation.
There's another question here.
I think none for now, sir.
Okay.
For the presentation of plaque of appreciation, may we call Engineer Arnel Avellino, Vice Governor for External Affairs in IECEP Cavite Chapter. Dr. Arnel.
Thank you. Can we share the virtual certificate, please?
Here po, sir.
Thank you. So in behalf of the Institute of Electronics Engineers of the Philippines, we would like to award this plaque of appreciation to Engineer Juan Carlos L. Lam, PECE, for sharing his time and experience during the first IECEP Colloquium on Power and Clean Energy with the theme Empowering Digital Technologies for the Advancement of Clean Energy and Power Engineering via Zoom. This February 12, 2022 from 8 o'clock in the morning to 6 o'clock p.m. Thank you so much, Engineer Juan Carlos Lam. A virtual round of applause. Thank you.
Thank you also, IECEP.
Thank you, Engineer Lam and Dr. Arnel. So we will now have a 10-minute break so you can stretch and refresh and please be back at exactly 4:20 p.m.
Electricity plays a critical role in keeping our world running. Managing the cost, safety and efficiency of that electricity is paramount. ABB's advanced monitoring and diagnostic systems help make sure you're fully in control of your operating expenditure, as well as minimising ongoing maintenance costs of your panels. You can significantly reduce the possibility of catastrophic failure. No one expects downtime to happen to them, but when it does, the impact on any business can be significant. On average, the cost of downtime to a data centre is $740,000. By giving you complete oversight of your operations, total cost of ownership can be reduced by up to 40%. ABB's digital infrastructure helps keep your personnel safe too, with remote diagnostics, removing the need for engineers to regularly enter the dangerous arc flash zone. ABB Ability Asset Manager is ABB's online condition monitoring system. By collecting diagnostic information across all medium voltage and low voltage switchgear and circuit breakers, it replaces conventional scheduled maintenance with a reactive condition-based approach, so you can predict equipment faults before they happen. All your critical data is stored centrally in the cloud using state-of-the-art cybersecurity provided by Microsoft and ABB Ability, giving you direct access to specialist assistance and real-time alarms. Protect, analyze and optimize your electrical systems with ABB Ability Asset Manager. Let's write the future of safe, smart and sustainable electrification.
Electrification is fundamental to our lives. ABB technology has always been at the forefront of innovative electrification, but that's only the beginning. The strategic role of electrification is growing, with urbanization and the world forging ahead to create a lower carbon future. We are developing digitally connected ABB Ability-enabled solutions for our customers with our more than 50,000 employees. The future of mobility is electric too, and we are building the charging infrastructure to allow the world to move from fossil fuels to electricity-driven mobility. Digitalization has paved the way to new and safer electrification solutions that better serve our customers and society.
Let's write the future of safe, smart, and sustainable electrification together.
Let's write the future together. ABB.
And manage the energy costs by giving your buildings a new dimension, relying on simple and intuitive digital solutions that allow you to manage and supervise every energy parameter anytime, anywhere. Discover ABB Energy Management. Smart, safe, sustainable.
Okay, a few minutes before we start and to resume on the final topic for our webinar. Are you still there with us? You may comment your name and your IECEP chapter on the chat box for us to know that you're still here. Okay. We also like to thank our sponsors, ABB. And if you want to join the Power Electronics team, you may search their private Facebook group. It's One IECEP Solar PV System Specialization Group. Okay. 2 more minutes.
Engineer Rai, if I may, Engineer Russ.
Yes, go ahead,
Yes.
Brad MP.
Yes, sir.
Yes, thank you very much for the energetic presentation, guys. No, so this is
We're
it.
all welcome.
Yep, thank you very much. Yan, so as you can see, mga ka-IECEP, it's no joke, no. This is our society, no, na that we really need you guys right now. So as you can see, napaka very informative na mga topics that we have discussed so far. For 4 topics that we have discussed, I don't think you're not interested on this one, but of course, we really need your help, guys, to fulfill our dream, no? So this is it. As mentioned nga ni Brad Russ kanina, this is our profession, this is our our scope, no? So with this, guys, no, I really need your help. We, the organization, the chapters, the societies, no, yung ating IECEP Power Electronics Society, no, is really need your help, no. As mentioned nga kanina, our priority right now, no, just to inform the audiences, no, sila Engineer Joel Arjona at saka si Brad Engineer Job Maya IV are in charge right now sa codes and standardizations, no. Tapos si Dr. Angela Beltran, andyan po sila sa sa research and development, no. Okay. So having said that, no, guys, we really need your help to fill those gaps, no. Please do join us sa Power Electronics Society, particularly sa sub-specialization group ng solar. As you can see naman, yung piniresenta ni Engineer Lam kanina, that is number 10 doon sa listahan natin, no. So if you can see, if I'll show my screen again, no, nandun po yung ating yung item number 10, no, yung smart grid. I will show again the presentation for the meantime, no. Pakita ko lang saglit. Okay. So as you can see, no, sorry. All right. So dun sa number 11, no, yung renewable energy system, nandyan na po yung one IECEP solar PV system sub-specialization group. Now, yung pinaresenta kanina ni Engineer JC Lam is a game changer. Iga nga. So this is a game changer definitely, but as mentioned nga, no, kanina, we need to standardize. We need to come up with the best practices that we need on the ground and consolidate those practices into a framework, no. So that framework actually, guys, is what we need, no, to submit to our IECEP National for their review and to challenge us on what is really our scope, no, pagdating dito sa mga bagay na to, sa technology na to. So having said that, we really need your help, guys, to fill those gaps. So we still have 1, 2, 3, 4, 5 hanggang 10, no? So 10 subgroups that we need, no? So we are going to pattern this dun sa international standards, no? Like IEEE and IEC and ISO, no? So if you are interested, please do join us by joining our Facebook group, or you may contact me directly sa Facebook. All right. So that's all, Engineer Rai and Engineer Russ. Back to you.
Okay, thank you very much. Engineer Rai, as you see in your touchback, I can give a shout out for all the IECEP chapter. I will do it one by one, Engineer Rai. Okay, may I call the IECEP Pampanga. Can you type in the letter Y? Engineer Rai, can you see the chat box if there's letter Y for IECEP Pampanga? IECEP Pampanga, are you here with us? Still with us? Okay, IECEP Manila. Can you type in letter M for IECEP Manila? I think we have a lot of M's. How about Cebu? Ato Nibay. Type in letter C for Cebu. And Cavite. Please type in letter C for Cavite. So, who else? Davao. Ato Nibay. Yes, right. There's a lot of letters coming in. Letter D for Davao. Okay, so meron pa bang naiwan? Bulacan, by the way. Yes,
I think we have from Bicol.
Bicol as well. Shout out to Bicol chapters. Thank you very much. So, Zambales as well. So, thank you. So how about Batangas? I can see Batangas. Okay, thank you very much, fellow professionals, students, to make this a wonderful activity for our first colloquium. Okay, now, so I have a lot of messages. Oh, KSA, Saudi Arabia, by the way, don't forget our professionals in the Middle East. So, Oman, okay, QC, Quezon City, Rizal, oh, whoa, Cagayan Valley as well. I can see a lot of it. Bataan, Car. Wow, it's so amazed with these activities. A lot of participation. Collaboration is the key to success for our Apo. Okay, Nueva Ecija. Wow, I can still more. Quezon Province. Thank you. Welcome aboard. We have still more. Iligan as well, Rai. Wow, too much, Engineer Rai.
Yes, sir. We are 269 on our attendees list.
Yes, totally perfect. We have still one more. CDO, Cagayan de Oro City. Wow, there's another Rai. Soc Sergeant. Wow, so Mindoro as well, right? So what an amazing collaboration. So anyhow, thank you for everyone. So we will proceed with our fifth topic. Engineer Rai, the e-space is yours.
Thank you again, sir Russ, and thank you to the 268 attendees for the first colloquium on power and energy. Let us move now to the introduction of research speaker. May I call Engineer Irvin Lakino to introduce our speaker in behalf of Engineer Jose Espinosa. Engineer Irvin.
Thank you, Engineer Rai, and thank you, Engineer Ras. For our fifth speaker, may I present to you Engineer Francisco Alano. He received his bachelor's degree in electronics engineering from Adamson University, Manila. He was a former SAP developer for SAP at Accenture, means also on AWS Information System, and a former EC instructor at Southern Luzon State University in Lokban, Quezon. Engineer Francis Alano is a registered electronics engineer, an electronics technician. He has two license. Currently, he is a candidate for the PhD degree in electrical engineering from Chung Yuan Christian University in Taiwan. His research interests include energy blockchain, control system, and machine learning. Without further ado, ladies and gentlemen, please help me welcome our speaker, Engineer Francis Alano, entitled Blockchain, a Revolutionary Technology for the Energy Sector. Engineer Francisco, the virtual floor is yours.
Okay, thank you for that introduction and good afternoon to everyone. So can everybody see my screen?
Yes, loud and clear with your screen. Very vivid. Go ahead.
Okay, so my topic for today is blockchain, a revolutionary technology for the energy sector. So here's my topic outline. So for the first part of my presentation, I will be discussing about the blockchain system. So I will be focusing on the basics and the different types of blockchain. And for the second half, I will be discussing how this technology can be applied to our power system. So first, for the introduction. So here I want to present first the factors why we want to use blockchain in our energy system. So first, we have the growth in electricity demand. And other than that, we also want to transition to renewable sources from fossil fuels. So we also have to consider the problems in renewable energy sources. So the intermittency of these sources, like for example, solar PV. So we only can generate power during the day. Or our wind turbines, when we can only generate when there is wind. So to mitigate these problems, we can use energy storage systems like batteries. But the connection of batteries to our grid also presents its own challenges. So here, just to give an idea of the increase of energy demand. So the projection here is from 2020 to 2050. So the trend just keeps on increasing. Okay, so more on the factors that are affecting the power system right now. So now we have household PV as well as their batteries. In turn, they have the option to sell their excess energy to the grid. So they are both producers and consumers. So as stated by Engineer Lam earlier, these are what we call prosumers. So they can either buy or sell electricity. Now let's proceed to the blockchain system. Now for a little bit of history. So the idea of blockchain dates way back to 1991. So way before it became popular in media. So the first blockchain was created by Stuart Haber and Scott Stornetta. So the idea is to make a distributed computing system. And in 2009, the first cryptocurrency was introduced by Satoshi Nakamoto in the form of Bitcoin. So Bitcoin is the most popular cryptocurrency today. And then in 2014, so Ethereum was introduced. So the difference between Ethereum and Bitcoin is that Ethereum uses smart contracts. So later, we will detail what smart contracts mean. And then around 2018 up to now, we now have industrial applications of blockchain. So it's not only for storing cryptocurrency, but we have many different applications as well. Okay, so let's start with the definition of blockchain. So it's a digital ledger similar to a database. So for example, when we consider a traditional ledger, so we have each entry in a logbook, let's say. So in each entry, there are details like the date, time, the information needed, the people involved, and the signature. So in a blockchain, it's very similar, only it's already in digital form. And then transactions are handled in peer-to-peer fashion. So what is peer-to-peer fashion? So here we have a comparison between a centralized and a peer-to-peer network. So in a centralized network, so for example, in this image in the left, we have a server, and then a lot of devices are connected to the server. So what happens here is that, for example, the server goes down, the entire network will be shut down. So in comparison, we have the peer-to-peer network where we don't have a central server, but the devices themselves are interconnected. So what happens is that only one of the computers need to, or rather one of the devices, not necessarily computer, will start the network. So let's say, for example, this computer right here starts a network. So it starts a peer-to-peer network and all of the other devices can connect. But what happens is that, for example, this computer which started the network goes down, the other computers can still continue the network. And then next, this is how a blockchain is formed. So it's constructed from many blocks that contain information. So for example, one block contains one entry. And then when that's recorded, another block will be connected to it. and recorded, and so on. It keeps on adding. The records are kept in multiple computers. So we go back here. So in the peer-to-peer network, so not only one device is keeping the blockchain, but all of them have the copy of the blockchain. And then the variations are tracked. So I will explain later how this works. And then here, so to start a blockchain network, we have the first block called the Genesis or block 0. And then it is encoded using the SHA-256 hash code. And then the succeeding blocks will be copying the hash code from the previous block. So I will show it here. For example, the Genesis here, the Genesis or block 0 has its own hash code. And then when we start our transactions or our recording of information, so block 1 will be the first one. So if you see here, for example, this is the hash of the Genesis. It will be copied onto block 1, and then it will have its own hash code. So sometime later, another transaction will be completed. So here we have block 2. Again, it will copy the hash of block 1 to itself. And then it will create its own hash, and so on. So this is what it means to track the variations in the blockchain. So each block copies the previous hash so that it knows where it is connected to. Okay, so here's an example of a Genesis block. So the main issue of the Genesis block is that it has no previous block to connect to. Now, what we want in the Genesis block is some authenticity on when it was created. So here in a blockchain, the timestamp is very important. And for this one, for example, let's say, here's the information. So if we can see here, it says the times 3rd of January 2009. Chancellor on the brink of second bailout for banks. So what it did is that it took the headline of the day. So this is to prove that this block was created on that exact date. So here are the properties of a blockchain. So it is automated, meaning it purely relies on code and digital information. It is secure because the data is stored in multiple computers. So unalterable. Now, once a block is connected and already stored in a blockchain, you cannot change it anymore. Because as we said earlier, there is the hash code and they're all interconnected. So you cannot change it. So it is private. The users of a blockchain are anonymous. But there are instances when we can change that. Next, it is distributed. So it's distributed in the entire peer-to-peer network. So all of them have a copy. And then timestamp. So the specific time which each block is created is recorded. Now here are the transaction steps. For example, someone is mining for Bitcoin. So first, a transaction is requested. So once the transaction is already filled up, so it will automatically create a transaction block. So this transaction block will be transmitted to the entire network. Now, each of these computers or each of these devices will validate if the block contains the correct information. Once all 4 of these validate the new block, they will receive rewards. it's in cryptocurrency. After that, the new block will be added to the existing blockchain, and the update will be copied to the entire network. Now, once that process is complete, we can now continue to another transaction. So for example, so this is the case if the transaction is successful. But what happens, for example, if this one is a bad block? Like there is some inconsistency with the hash code or the timestamp, or let's say it's an attempted hack. Now what happens is that the new block will be rejected, and then it will be recorded across the network. And what happens there is that the user who attempted to create that block will also be recorded. So it will not be included in the blockchain records, but the network will, let's say, remember who did the attempted hack. Now let's proceed to consensus algorithm. So in a blockchain, we have two ways to categorize them. First is the consensus algorithm, and another one is permission model. So I will discuss about the permission model later. But for now, let's focus on the consensus algorithm. So we need this because blockchains can still be hacked using fast computers. Now, even if the ledger is distributed among a network of devices, and even if the variations are tracked, so using really fast computers, it can still be bypassed. So to mitigate that, consensus algorithms are used to verify. So we have I've shown here three types of consensus algorithms. So the most common one is proof of work. The following is the proof of stake. And third one is proof of authority. So there's actually a fourth consensus algorithm that's also common. It's called the practical Byzantine fault tolerance. But for the sake of using it in energy blockchain, so it has a problem with scalability. So for the purpose of this seminar, we will focus only on these three. Okay, so let's start with proof of work, the most famous one. First is miners compete to solve a cryptographic puzzle. Now this is what is done to mine for Bitcoin. So the first miner to solve the puzzle is rewarded. Now, when you are able to successfully solve a cryptographic puzzle, you get a reward in personal digital wallet. The problem with this one is that mining communities tend to become centralized. So because in proof of work, the competition is always about computational power. So the one with the most computational power will be able to always successfully mine Bitcoin, and they will not be able to leave chance for the others. Now, maybe some of you are familiar. You have already seen mining rigs like this. So it's full of GPUs dedicated for the sole purpose of mining Bitcoin. So to counter that problem, proof of stake was created. So proof of stake, to put it simply, it relies more on investing rather than using computational power only. So users stake tokens in the blockchain network, and then the probability of revealing hash. So revealing hash, this is the cryptographic puzzle, which is mentioned earlier. So it is based on stake amount. So let's say there are three users here. So user one has the most invested money. The second one has less. And user number three here has the least amount of money. Now, all of these three will be participating as validators in the blockchain network. So normally in a proof of work, user one will be the most likely to always solve the puzzle. if, let's say, user 1 has the most computational power. But here in proof of stake, since it's based on the amount they have, the reward will be distributed depending on the amount of money they have invested. And lastly, we have proof of authority. So this is a modified version of proof of stake. So again, users have to stake tokens in the network. But instead of simply checking for the amount of money they have invested, they're also based on reputation. Now, when I discussed earlier about the, let's say, the attempted hack, so the reputation, that's what the reputation is about. So there could be an attempted hack or attempted fraud in creating the new blocks. And then sometimes there are also validators that try to authorize the creation of a block that's fraudulent. So here on proof of authority, the most trusted one will most likely receive the reward. Okay, so now let's proceed to the permission model. So in permission models, this mostly focus on who can and cannot join the blockchain network. So we have three basic ones. We have public, private, and the consortium. So first is the public. So anyone is allowed to join the network, and all of them have equal rights to create or validate the data within the network. So there is nothing stopping them from joining or not. So examples are Bitcoin, Ethereum, and Litecoin. So mostly on the cryptocurrency. So it tends to have long validation times. So these usually are really large networks of users. Now, if there are more computers or more devices connected to the blockchain network, then all of them have to validate the creation of each new block of data. If there are more of them, so all of them have to validate it, which results in taking up too much time. And next, we have a private blockchain. So this is controlled by a single organization. And then this organization will decide who can or cannot join within the network. Other than that, when they allow them to join, not all of them have the same rights. So some of them can create blocks but are unable to validate. Now, this will speed up the validation process, but it is also more vulnerable to fraud because they can just block anyone who they do not want to join the network. So it says here, the lack of transparency. And next, we have a consortium. So this is a modification. This is a modification of the private blockchain. So instead of just one organization, it's a group of organizations. So it has more decentralization than the private blockchain, but setting this up is more complex because so all of them have to agree on a certain set of rules before they can create the network. And then we have another one. We have a hybrid blockchain. So it's a combination of public and the private blockchain. So similar to a private blockchain, there's only one organization controlling it. But in terms of the functions, there are some properties within this network that the public can access. So this is to increase the transparency. So here, one example is that transaction validations can be executed by anyone within the network as long as they can join the network. So what happens is that the private organization will will allow people to join the network. They will choose who can join, but all of the participants can participate in validations. Okay, so let's proceed to the digital currency. Now, it could be any means of payment in a purely electronic form. So it's not physically tangible. Unlike the print money or the coins that we have. So in digital currency, it purely exists in the internet. It makes transactions cheaper and faster. So cheaper, not necessarily all the time, but it definitely is faster compared to our traditional way of transactions. Now we have 3 examples of digital currency here. We have cryptocurrency, we have central bank digital currency, and then there are also stable coins. So stable coins are usually in the decentralized finance sector. Now they are usually used for loans. Now it's called stable coin because it's directly tied to a national currency, for example, the US dollar. And then there are companies in the US that provide stable coins as loan. So you can buy property using that. But for our seminar today, we will just focus on cryptocurrencies. First, the most popular one, Bitcoin. So as mentioned earlier, it was introduced in 2009. As of now, it's the largest cryptocurrency by market capital. And then it served as the basis of the creation of other cryptocurrencies, which we see now. So being the first, it became the standard on which to create the other currencies existing today. Now here's the Bitcoin network power as recorded by the Cambridge Bitcoin Electricity Consumption Index back in 2020. So as we can see here, the power consumption of Bitcoin mining is really high. So this is what Bitcoin mining looks like. Now these entire racks are contain GPUs, or if anyone has already any experience of mining Bitcoin, we rely on computational power provided by the GPUs, usually from NVIDIA. So this example is one Bitcoin mining center from China. This was some time ago before they totally banned it. Okay, so let's proceed to the next example of cryptocurrency. So the second one is Ethereum. So it's open source, used usually for business and finance. And then there are transaction fees called gas. Now it is only second to Bitcoin in terms of market value. But the thing with Ethereum is that it's using smart contracts. Now this is very popular in the research because this is the basis for we can use blockchain for industrial applications. And then here we have Ethereum 2.0. So the first Ethereum is still based on proof of work, but here in Ethereum 2.0, it is now proof of stake. So what happens here is that everyone who already has mined Ether during the days of Ethereum 1.0 will still keep their Ether, and then they can use it to invest here in Ethereum 2.0. So that's how the transition from mining to proof of stake will work. And then next we have the smart contract. So in our traditional contracts, usually we have printed documents where we have to manually fill up, or sometimes they're even online, but still we have to manually type the entries. But in smart contract, we just have to execute a code. Everything is automatically filled up and then automatically sent for approval. And what's more is that there is no third party involved. So let's see a comparison how it works. So in traditional, contracts are in a form of a written document or sometimes online, but still have to be manually filled. Because of that, it will be prone to error because of human error. We can't that. Then intermediaries are usually present for the processing of a contract. Now here, for example, we have two parties that can agree and then they will fill up a form. But once the form is filled up, they will usually need the approval from a government body. So the processing in a government body usually takes a few days to a few weeks, depending on the type of contract. And after that, the contract is complete. But in a smart contract, so the contracts are simply codes. They automatically fill up and submit it to the network. So errors are eliminated through the use of automation. So the automation used here is the validation process showed earlier in the blockchain. So because of that, there's no need for intermediaries because the validation process is automatic. And because it's a code, it will be able to automatically detect if there are any errors or not. So here, for example, here we have two parties that agree on a purchase. So they will just automatically fill a smart contract, and after the validation through the blockchain network, the contract is complete. Then here we have multiple applications. So basically anything that uses a contract or anything that requires filling up a form can be replaced using a blockchain. For example, we have finance, we have logistics, intellectual property, so even in healthcare. And then here in real estate, so as I described earlier, the use of stable coins. So you can apply loans to buy property, but it will automatically be approved through the use of the blockchain network. And finally, for our topic today, we can use the blockchain in the energy sector. So now let's proceed to the energy blockchain. Now here I will show how the blockchain technology described earlier can be applied to the power grid. So first, let's define the energy blockchain. So to put it simply, it's blockchain technology used for energy trading. Now it works in combination with IoT devices like smart meters and others. So it was already mentioned earlier that in the AMI, the AMI will be automatically be able to gather data. Now what we're doing here is that we're using the blockchain. We're using the blockchain to help the transition to smart grid. So if we already have an existing smart grid infrastructure, a blockchain can be added there, and to complement, it will be able to complement the technology. So it will simplify the addition of renewable energy sources and prosumers. So how does it simplify it? So if we're still using the traditional way of for filling up contracts, it will take time for approval. But with the use of the energy blockchain, since all the contracts are processed automatically, everything will be faster. And then other than that, when connecting to an energy blockchain, there is this thing that can automatically adjust. Okay, so smart grid applications. Now each application can have its own specific blockchain. And here it can simplify the addition of grid users and increased security because of the use of the peer-to-peer network and the consensus algorithms. Here, let's say we have an example microgrid. Now here's just an example. Let's say we're using a proof of stake and private blockchain. So we will not be using proof of work because in proof of work, it will consume too much energy. So what happens if it consumes too much energy? It's counterintuitive to our purpose here. What we want here is to sell energy, not to consume too much of it. And then let's say it's a private blockchain. Now, just to recap, a private blockchain, there is only one central authority which is allowed to, which will allow participants to join. Let's say the authority would be the DSO. So the DSO will approve who can join the blockchain, and then it will also decide their role. So let's say there are energy producers. The energy producers can join the blockchain with the approval of the DSO. Or there are households that are purely consumers that can also join transactions. Let's say this wind farm will sell energy to this household. Now, when the transaction is initiated, it will create a transaction block. So it will be an agreement between this wind farm and the household here. But the validation process will be executed by all of the other energy producers in the area. Let's say the PV farm 1, PV farm 2, and then there's also household PV here. So this household here is a prosumer and will not participate in the validation. So this is to speed up the process of the approval of the smart contract. Okay, let's say we have an energy trading really focused on buying and selling. So all of the entities within the entire microgrid, these are the most basic transactions. And then another one, for example, we have the cyber physical security blockchain. Now, a blockchain is really secure, but it's still vulnerable to attacks. It's not really a perfect system. So we can create another blockchain that's purely focused on security, other than the transaction blockchain. Now, what happens here is that all of the entities can join. So let's say to increase transparency, all of them can participate here. And then, for example, it can be a different type of consensus for the sole purpose of increasing the security within the system. And then next, we can also have a really dedicated blockchain, such as one dedicated for solar energy. Now here we only have 3 participants, the PV farm 1, PV farm 2, and then the household that has its own PV. Now what they do, this is mostly for aggregation. Like we want to just to collect the information from all PVs within the same microgrid. And then this also gives the option for consumers. So for example, one consumer just specifically wants to buy solar energy only. So as discussed earlier, this is one of the features that has to be implemented when using a smart grid. So we can apply it here. And then another one, for example, we have purely wind energy, like one consumer wants to buy wind energy only. So here, the blockchain here can be checked. And then another one, another specific purpose of a blockchain for electric vehicles only. So another very specialized one. Also mentioned, this was also mentioned earlier in the smart grid. So if you can see, everything here in the blockchain is directly connected to a smart grid. So this is basically to complement and to make improvements and to make it easier to process everything from contracts to transactions within a smart grid. And then another one could be a microgrid operations blockchain. So let's say the utility is already connected, and then we have 4 interconnected microgrids. So for example, this microgrid wants to be islanded or disconnected from the entire network. So this blockchain will be able to handle it automatically. So through the use of AMI and ANA. It manages the connection, disconnection, and possibly also the fault which was discussed earlier can also be handled by this one. Now let's focus on the advantages and disadvantages. So advantage, there's no central management, except for initially. Because let's say, for example, the DSO will start the blockchain network and then they will give permission to who can join or not. It's resilient to attacks because of the distributed ledger. The transactions are easier because they are automatic, which needs no third party. Detailed and unchangeable history. So this may actually be a problem, the unchangeable history. Because there are times when the wrong information could be saved on a blockchain, but let's say it was validated. So it may or may not be an advantage. So this could be mitigated. And then shared information, although the users are anonymous. So disadvantage, is very expensive. So only at the start, and also ideally the smart grid must be implemented like 100%. So the blockchain totally cannot work if not everyone, if only a certain percentage is using smart meters, then this technology will not work at all. Other than the fact that the internet should be reliable, because this should be connected at all times. So here, smaller networks are less secure. But the thing with small networks is that the validation process will be faster. But if you make a larger network, the larger networks will be more secure, but the transactions will be slower. But these 2 disadvantages, we can just have we can select which one the proper size of the network. The transaction charges may be higher, but this is just for the initial deployment. And the validation process is repetitive. So in our traditional contracts, we only need to validate transactions or contracts once. But here, to increase the security, we will have all the participants do the validation process. And then here are the current trends in the energy blockchain. So here's the prediction made by Global Market Insights. So in 2018, the energy market in the US for blockchain is 200 million. And it is predicted to increase up to 18 billion by 2025. So here we actually already have standards existing for the energy blockchain here. So here it's IEEE P2418.5. So they have seminars here. So the engineers in IEEE discuss what can be improved, like the current situation of the standard, how they are implementing it in different cities around the world. And then they get the feedback from those countries, which can be changed or improved, or maybe let's say there are loopholes because this is still very new. The standards are still very new, so it's still subject to change all the time. And then since the implementation is not really that widespread yet, so it's still being changed. It's still in progress. So here are some already existing industrial energy blockchain. So as we see here, we have 12 examples here, but there are more. Let's say, for example, let's get the Power Ledger. So this is from their website. Currently, they have 11 countries. They're operating in 11 countries with 30 plus clients. And here's some example. They have in Australia, in Thailand, India, France, Japan. They have also very different applications as well. Now here's one example in Australia. They're only using it in a 5-story 39 apartment complex. So it's a microgrid. Now they're using 100% renewable energy, and which are using solar rooftop PVs. And then another one, we have a larger grid in India. So it's used to manage the PV system. So they're managing 2 megawatts of rooftop solar PV systems. Okay, so another example of the industrial application is solar coin. Now solar coin is very specific. From the name itself, so it's rewarding producers that produce solar energy. So here, when a customer proves they've generated a megawatt hour from solar technology, they create a solar coin. So this solar coin is the specific cryptocurrency they're using. And when they want to convert it to other currency, like in US dollar, so here's the price today. So for generating 1 megawatt hour of solar power, you can get this amount from solar coin. So this may not be a very large amount for now, but the thing with cryptocurrencies is they're not very stable. They fluctuate all the time. The value changes. Then here's another interesting article, but this was back in 2017, so it's a bit old, but I think this is still relevant in regards with our topic. So it says here, decentralized electricity could be blockchain's Trojan horse. So it might seem like a negative connotation to use Trojan horse, But the point here is that the use of blockchain today is like, let's say, it's like only a few people are interested, like only people who are very like enthusiasts for using the technology. But in electricity, we could probably see widespread use in the industry because of the advantages which were shown earlier in to make it easier to transition to the smart grid. Okay, so let me read this part first. The Grid Plus agent is a cryptocurrency-enabled general-purpose IoT device. So it is used for electricity markets. Although they state that electricity is just one of the first applications, the first industrial applications. So what is the Grid Plus? So this is the Grid Plus, which can interface. Now this device is called the Lattice one. It's a digital wallet which can store cryptocurrency, which can be used to buy electricity. And then there's the safeguard. So for those familiar with cryptocurrency, there's this plugin in the web plugin called MetaMask. So that could be your digital wallet. So it's stored online. But here in Grid Plus, you're using a IC card. And then finally, to summarize, here's the projected growth of the blockchain market, still from the same source, Global Market Insights. The regions that are most focused on is US, Europe, and the Asia Pacific region. So for the period of 2019 to 2025, the growth rate is projected to be 50%. Okay, so that's for my presentation, and thank you for listening.
Okay, Engineer Alano. Thank you for much taking time to share a new topic with us, especially in this group. What a great topic, Engineer Alano. I was intrigued by the technology. Again, fellow ECEs, professionals, and students, as mentioned by our speaker, networking is part of this topic. It is our area of specialization. Therefore, it is time to shine in the energy sector. Okay? So don't worry, we have a plethora of specialization to choose from. Now let's proceed with the Q&A portion, followed by the awarding of plaque appreciation, then the photo oaths. May I call Engineer Jericho Sevilla to please plus in the question? Please do so. Or our technical team for the Q&A. Okay. Engineer Alano, here's the first question. So you can answer it directly. Go ahead, Engineer Alano. You can do it.
Okay, so the question asks is how much would be the investment of an ordinary household would invest in solar energy? This actually isn't really part of my specialization, because my specialization actually is more focused on the research aspect of it. This is already in the implementation side or the industrial side. Because right now what I'm doing is to simply prove how the blockchain could work in the power grid. But when it comes to the actual money that's needed, this is a better question for those who are really involved in the project of deploying a blockchain. So I apologize, I will not be able to answer this question.
It's okay, Engineer Alano. By the way, Engineer Fee, maybe the committee will give you the right response to your question. The committee, please do so if you have the right question in the Q&A portion. Next, let's go to our question number 2. Technical team, please flash in our second question.
So for the question number 2, from Engineer Russell Torres, speaking of bad actors or cyber crime, how is the blockchain affected, or at what level, high, low, or zero in terms of vulnerability? Engineer Alano.
Okay, so thank you for this question. Now, at what level? So I wouldn't really say that the vulnerability could be high or low, but if it's definitely not zero. So there were cases, let's say around 2 years or even more. There was an article about Bitfinex. I think it's Bitfinex. So around 2016, I think. And then what happened is that a lot of a really large amount of Bitcoin was stolen. And the problem with that is that so cryptocurrency is the anonymity of the users are guaranteed. So that's actually one of the trade-offs. So the risk is not really high, but I can say it exists. And then there's another case. So if you're familiar with NFT, so NFT is also in blockchain, but it involves more of artwork, but it's also vulnerable to theft. So it is still vulnerable to cybercrime, but so this is mostly due to the fact that it's still a new technology. So there, I hope I was able to answer your question.
That would help enough for that. So meaning there's still vulnerability, even 1 or 2, but still there's possibility of hacking. Now, do we have any question, Engineer Rai, to be flashed
Yes,
in?
we do
Go
have.
ahead. Go ahead, Engineer Rai.
Okay, for question number 3 from Engineer Andre, aren't miners using ACIC's application-specific integrated circuits now instead of GPUs? Aren't miners using ASICs now instead of GPUs? Engineer Alano.
Okay, so thank you for this question. So I've been hearing about this recently, but the thing with GPUs is that they're easier to purchase compared to that. And then with GPUs, everyone can buy. And it's also easier to set up. So they prefer the use of GPUs.
Okay, thank you very much, Engineer Francis. I think there's another one more question coming in. Technical team, please flash in again our question number 4. Hopefully, Engineer Ray, there's a lot, but we have to cut in. Okay, how much will be the cost for applying blockchain by Engineer Herman? Go ahead, Engineer Francis.
So what I understand is for applying a blockchain. So this could mean different things. So I'm thinking if, let's say, you want to mine Bitcoin or Ethereum. So the cost would be really your investment in buying the necessary hardware. And because computational power is used for now, so that the electricity cost would also factor in. But if you're saying about creating your own blockchain, so that would be an entirely different thing. So of course, you still have to invest in the devices you need to start the network. But the cost, so it depends on how you create your coins and how that coin will be viewed in the stock market to have any value. So there's no specific answer for this actually. So this could be better left for the people in the finance sector.
Okay, thank you so much, Engineer Alano. We could take this question, and then for those who have additional questions, we still have time. Can we flash the next question? Maybe okay. What affects the rate of gas fee from Engineer Mark Kiambao? Engineer Alano.
Okay. So the gas fees in Ethereum. So the factors that affect it usually are the traffic within the Ethereum network. So if there are more transactions that should be handled at the same time, so the gas fees would increase. Or if the transaction is more complex, it could also increase. So that's just in the Ethereum part. And then another factor could play in is the exchange rate between Ethereum and let's say the US dollar. So there are a lot of factors, but the most important points are the number of transactions and the complexity.
Thank you, thank you, Engineer Alana. I think last one question. The topic is so interesting. Okay, go ahead, Jericho. So in your research, do you think the pros of utilizing the crypto in our grid is enough or greater than the increase of power consumption it needs, from Engineer Adrian Braza?
Okay, so utilizing crypto in our grid is enough or greater than the increase of power. I'm sorry, but what's the increase of power consumption? So based on my understanding, you're concerned that the implementation of blockchain will increase the power consumption. Yes, so this is one of the problems that is focused in research. So as I mentioned earlier, it would be counterintuitive if we're using a blockchain that would consume too much energy. So that is why we're using different consensus algorithms and permission models. So we can balance the trade-off between the increase of power consumption by applying the use of blockchain, as well as increasing the security and making sure that the convenience of the producers and consumers are met. So that's it. It's more on the trade-off, really.
Thank you so much, Engineer Alano, for answering all of the questions. Again, if you have additional questions, you can drop them in the Q&A box, and we will reach out to you for the response. Engineer Russell, the floor is yours.
Okay, thank you once again, my co-host, Engineer Rai. Okay, let's proceed with the awarding of plaques of appreciation. May I call in Engineer Alvin, the Vice Governor of IECEP Mindoro. Engineer Alvin, the e-space is yours.
Thank you, our very energetic Engineer Ras. Parang gusto kong mapagaya sa style ng iyong pagkasalita. Anyway, if we can please flash the certificate to our screen for everyone to see. Sa ating technical team, if we can please
Okay, sir.
flash the There you go. Okay, so allow me to read the plaque of appreciation. On behalf of the Institute of Electronics Engineers of the Philippines, we would like to express our gratitude to Engineer Francis I. Alano for sharing his time and experience during the first IECEP Colloquium on Power and Clean Energy with the theme Empowering Digital Technologies for the Advancement of Clean Energy and Power Engineering via Zoom meeting on February 12, 2022 from 8 a.m. to 6 p.m. So once again, thank you very much, Engineer Alano. Please receive this plaque of appreciation virtually. Let us give him a virtual applause.
Thank you very much for this opportunity.
Engineer Francis, stay put. I would like to request the panelists and our speaker for our photo ops. Please do so. Thank you once again for asking for our attendees. Just stay put. We will do our link for the Google form. You will not be missed. Thank you very much for all attendees. At the very end, we are still here. Okay, our Miss Faye, please advise us if you have already done our beautiful faces and handsome faces of this webinar.
On the count of three, Paul, let's smile. And 1, 2, 3. Thank you very much, po.
Yes, that was a good 1, 2, 3 count. Now, let's proceed with further announcement. I would like to call in again my co-host, Engineer Rai, for the announcement. Engineer Rai, the e-space is yours.
Thank you, Engineer Russell. So for further announcement, I would like to remind everyone from the Institute of Electronics Engineers of the Philippines, IECEP Chapters Batangas, Cavite, Cordillera Administrative Region, La Union, Pangasinan, and Pampanga and Tarlac, they will be having their ECE workshop tomorrow entitled Kung Hindi Ngayon, Kailan Pa? Upgrade Now, the Journey to PEC workshop tomorrow at 1 to 5 p.m. So we have different speakers and panelists from the different chapters. Additional also, we'd like to thank our sponsor, ABB. And if you still want to join on the Power Electronics private group, you can add or join them on Facebook from their private group. It's One ICEP Solar PV System Subspecialization Group. Okay.
We have more? Please do
That's
so.
it, sir. That's it, sir.
Okay, thank you very much. In a movie or a film, you're watching movie, by the way, there always an introduction or an action that it's the message is the start of the movie. However, there is also an ending. Like in this virtual webinar, we have a closing remark. However, this closing remark is not an end. If you're watching Netflix series, there always an interesting topic on the chapter 1, 2, and 3, and 4. But we will give you that one. It's depend and how you respond to our call. Now let's proceed to our closing remark. May I call Engineer Dixon, the IECEP Power Electronics Society Secretary, for our closing remark. Engineer Antonio, the e-space is yours.
Thank you, Engineer Russell. Can you hear me?
Yes, loud and clear. Go ahead.
Thank you. Magandang hapon po sa ating lahat. Good afternoon, everyone. On behalf of IECEP Power Electronics Society, we would like to thank all the participants who tuned in and stayed with us throughout the event. Indeed, we have learned a lot about power and energy sector, focusing on digital and emerging technologies. This event wouldn't be possible without the guidance of our Almighty God, the dedication of IECEP National in safeguarding the mandates and practice of electronics engineering profession in the country, the support of our resource speakers from the academe, government, and industry who shared their expertise and knowledge today. Let's also acknowledge the help of the hardworking IECEP chapters. We have IECEP Bulacan, Cavite, KSA-CRC, and Mindoro. We also had some help from our dear student volunteers from St. Louis University and University of Baguio in the Cordillera Administrative Region. Furthermore, please watch out for the upcoming activities of the different IECEP chapters and especially IECEP Power Electronics Society. We're still looking for volunteers to join the group to help in the advancement of power electronics. If you're interested, please do notify us and we are excited to have you on board. On a final note, let's collaborate and work together to achieve sustainable cities and sustainable future. Thank you for the attention. Maraming salamat po at mabuhay po tayong lahat.
Thank you, Engineer Dixon, for that wonderful closing notes. But before that, we have a final words from my co-host, Engineer Rai. Please do so. The e-space is yours.
Thanks again, Engineer Russ. So again, for those who want to know how to qualify for e-certificates, reminder to don't forget to sign in your attendance form, pass the evaluation test, and accomplish the webinar evaluation survey. So I think we're all waiting for this one. Ms. Faye, can you please share the evaluation link?
Engineer Miss Pei, please do so if you're ready. By the way, while waiting for the screen, so thank you very much. I would like once again to thank you all the attendees, professionals, students, to make this event successful, and also to our hardworking team, our fellow engineers of this committee. So, how you find the activity, Engineer Rai, for today's activity?
I think we have many different interesting topics, and uh, as as we go along on our career in electronics engineering, I think we really need to explore the topics discussed this afternoon. By the way,
Yes.
for the link, I think it's now available on the chat box. And again, this is the first colloquium on power and energy with the theme Empowering Digital Technologies for the Advancement of Clean and Power Engineering, organized by the IECEP Power Electronics Society and hosted by IECEP Bulacan, IECEP Cavite, IECEP KSA-ERC, and IECEP Mindoro Chapters.
Okay, once again, thank you and have a nice day, everyone. And don't forget to like our page, our FB page, ISEP Bulacan, ISEP KSA-CRC, ISEP Mindoro, or our specialization group. Engineers, any words to say before we end the final event?
Thank you. I've seen comments on the chat box. Thank you, Sir Ross,
Yes,
and to
go
all
ahead.
the
I think we're all already come to a final for this day. Thank you, everyone. Thank you very much. Okay, don't forget for your attendance. It's in our link. Please do so. MP, have some words because it's already free for everybody.
And congratulations sa atin lahat mga ka-ISEP, no? It's a very very successful webinar that we have conducted this Saturday, no, February 12. It's a Valentine Day salvo natin, no, mga ka-ISEP, no. So congratulations and good luck and God bless to us all. Thank you.
Yes, panelists, if you have some word to say, please open your mic. This is our chance.
Sa ating Power Electronics Society. Congrats.
Yes, this is for us.
Congrats po.
Dance.
Thank you po sa mga nag-participate. Keep safe po. God bless.
Sa mga gusto magpa-member na Rod Russ, let's invite them.
Yes, once again, we have still 232 attendees still online. We need you. As you shown on the screen by our chairman, we have still a lot of specialization on different fields. If you are on those specialization, you need on this group. Please visit our FB page, okay? Or you can type in our chat box if you have some specialization or skills on that field. So it's very helpful. The more, the merrier. Okay? So, once again, please do so. So from panelists, if you have something to say, please open your mic. This is our chance. Okay, thank you very much.
Thank you, Engineer Res. Again, this is Rai Angelique Agda from IECEP Bulacan chapter, and together with my co-host, Engineer Russell Vincent Torres, and also with the AM moderators, Engineer Grace Valila and Engineer Dominic Marquez, we thank you so much for participating on this event. Have a nice day.
Enjoy the weekend. Valentine's. Happy Valentine's.
Okay, I think Engineer Rai, we're still 218 on the chat box. So I think 200 plus. I think they're here to hear more from us. So anything from the group while people are still here? So it is our chance to advertise our group. So people who are in this specialization, once again, we would like to call in to participate and join this group. So we will make IECEP better for our future. So knowledge is the key. Knowledge sharing is more powerful. Yes? MP, go ahead.
We can flash on the screen yung ating AVP sa Power Electronics.
Yes, please do so.
We'll still have audiences so we can promote
Yeah,
our...
we have still 200 plus.
Right. Congrats, everyone. Congrats.
Yes, IECEP Oman, thank you for being with us. Davao, thank you very much. So I think we're waiting for the flashing of our specialization. So Engineer Joey, anything to say?
Okay, congratulations for first colloquium webinar ng Power Electronics Society. Success.
Yes.
Thank you po sa hard work, Sir Tony, sa lahat po ng mga PowerPoint and everything. And sa lahat po ng chapters, congrats po sa atin. Cavite, Mindoro, KSA-CRC. Thank you po sa lahat po ng hard work. Magov, thank you po.
Yes, hopefully we will have the series 2.
Yes po.
Erwin, yes, go ahead, Erwin.
Thank you
Erwin,
very
go
much,
ahead.
Engineer Donald Piquera from Bulacan, Gob ng Bulacan. So thank you very much. So wag ka madadala sa Power Electronics Society.
Hindi madadala yan. Brad Erwin.